Aircraft lined up on approach to DCA can be seen in the right corner of the screen. The flashing lights identify the touchdown zone of runway 33's landing threshold. Flight 5342 is visible in the upper left corner as it approaches runway 33. PAT 25 appears from the left side of the screen, moving to the right as the two aircraft cross flight paths. This concludes the animation.
Thank you, Mr. Banning. We're going to turn to the first panel. So Dr. Bauer, will you please provide an overview of the panel topics and introduce the technical panel and the witnesses?
Chairwoman Hamady, the first panel is overview of the accident helicopters, air data systems, and altimeters. The panels will address helicopter static pressure and pressure altimeter systems, static system error and instrument error of the altimeter, total error effects on the accuracy of barometric altitude, military and civilian design requirements for helicopter air data systems and altimeters, design challenges for helicopter air data systems and altimeters, helicopter altimeter accuracy, standards, checks, and verification, and how accuracy of parametric data is verified and maintained for both civil and military flight data recorders. The NTSB technical panel, starting on my right, is composed of Mr. Chihoon Shin, aerospace engineer, helicopters, Ms. Marie Moeller, mechanical engineer, vehicle performance, Mr. Sean Payne, branch chief, vehicle recorder division, and Mr. Michael Portman, aerospace engineer, recorder specialist. Witnesses for panel one are composed of the following individuals, starting from my left, nearest the board members. Mr. Dan Cooper, Senior Technical Fellow for Avionics, Systems Integration and Test with Sikorsky. Mr. Lance Gant, Chief Scientist and Technical Advisor for Rotorcraft with the Federal Aviation Administration. Chief Warrant Officer Kylene Lewis, Department of Evaluation and Standardization with the U.S. Army. Mr. Steve Bradham, Chief Airworthiness Engineer with the U.S. Army, and Mr. Scott Rosengren, the UH-60 Chief Engineer with the U.S. Army. Chairwoman Hamady, these witnesses have been pre-qualified and their respective experience and qualifications appear in the docket as exhibits.
Thank you, Dr. Bauer. Will the witnesses please stand? Please raise your right hand and answer by saying, "I do." Do you swear or affirm that the testimony you will give in this hearing will be the truth? Thank you. You may be seated. As a reminder to the witnesses, you'll remain under oath until the conclusion of the hearing. We ask, and this is very important, we ask that you answer questions factually. Please avoid analysis or any speculation. If there's a question about the question, if it leads to speculation or you think it might, just direct the question to me and I'll make sure to clarify. Also, I'm going to ask our staff, we've already talked, but just a reminder, and then also the witnesses, please do not use acronyms. We all use it frequently. But there are a lot of people, both in the audience and watching virtually, who don't know what those acronyms mean. So we want to make sure that they can follow along. So please try. I know it'll happen, of course, but if we can try and do our best, I think that would be much appreciated. Finally, you have microphones ahead of you, so just push the microphone button to talk and push it again when you're finished. Thank you so much for being here, and I'll turn it over to Mr. Shin.
Good morning. We will begin panel 1 of this investigative hearing with a presentation from myself and Ms. Moeller. The purpose of this panel is to discuss the air data system and altimeters on the UH-60 Black Hawk helicopter. Investigators identified discrepancies related to the accident helicopter's altitude, leading to additional investigative work to determine the validity of the altitude information displayed to UH-60 pilots and the altitude data recorded by the helicopter's Flight Data Recorder, or FDR. To begin, it's important to start with some definitions of altitude, which is an aircraft's height above some reference point. In this image, there's an example of 2 different ways that altitude can be measured: above mean sea level and above ground level. We will discuss pressure altitude, which is then corrected to height above mean sea level, and radio altitude, which is measured by bouncing radio waves off a surface below the aircraft to determine its height above ground. A third type of altitude, GPS geometric altitude, will also be referenced. Generally, atmospheric pressure decreases with increased altitude. The air is thinner on top of Mount Everest compared to near sea level, such as Washington, D.C. The International Standard Atmosphere Model, or ISA model, defines an altitude for a baseline pressure of 29.92 inches of mercury at sea level. If you measure the static air pressure around an aircraft, it can be compared to the ISA model to determine how high the aircraft is. However, as you know from weather forecasts, atmospheric pressure can change, so a correction factor for local atmospheric conditions is needed to be applied to more accurately determine an aircraft's height above sea level. A barometric altimeter is essentially a barometer that measures static air pressure and displays an altitude in feet. The image on the right shows a UH-60 barometric altimeter. Local atmospheric conditions that necessitate a correction factor can be applied to the altimeter using a barometric adjustment knob. This local altimeter setting corrects the ambient pressure altitude to the helicopter's altitude above mean sea level. The barometric setting for the altimeter is shown on a 4-digit counter in the altimeter setting window, also known as the Colesman window. Local altimeter settings are broadcast on Automatic Terminal Information Service, or ATIS, and by Air Traffic Control, or ATC. Multiple cockpit instruments, including the barometric altimeter, measure static air pressure surrounding an aircraft as part of their function. Static ports supply static air pressure to these instruments via a series of tubes. Static ports can be located on the fuselage as shown in the yellow arrows in this image. Static ports can also be incorporated into a pitot tube, which is called a pitot-static probe. The UH-60 helicopter, as shown in the image on the right, has 2 pitot-static probes that are located on the left and right sides of the cockpit roof, immediately aft of the cockpit doors. The UH-60 helicopter has 2 independent static systems, identified as Static 1 and Static 2. Each pitot-static probe has 1 port for its pitot system, 2 ports for its Static 1 system, and 2 ports for its Static 2 system. The right pilot's barometric altimeter uses static air pressure from the Static 1 system, while the left pilot's barometric altimeter uses static air pressure from the Static 2 system. The simplified diagram on the right shows how the Static 1 system supplies static air pressure to the right pilot's barometric altimeter. An air data transducer also uses static air pressure supplied by the Static 1 system. Outputs from the air data transducer are used by multiple helicopter systems. One of these systems is the remote data concentrator, which receives uncorrected pressure altitude data and supplies that data to the Integrated Vehicle Health Monitoring System, or IVHMS, which includes the Helicopter Flight Data Recorder, or FDR. Next, Ms. Moeller will discuss the pressure altitude data from the Black Hawk's FDR that was analyzed for this investigation.
With that explanation of pressure altitude and barometric altimeters, I'm now going to discuss the altitudes recorded by the accident helicopter. This plot shows the FDR recorded pressure altitude in blue for a portion of the flight. The blue dotted line is the pressure altitude corrected for the local altimeter setting. The red line is what we determined to be the actual height above sea level of the helicopter based on radio altitude and terrain, which will be discussed further in the next slide. The Army crew was trained to fly the helicopter routes around DCA using the barometric altimeter. The triangles show 3 pilot altitude callouts recorded on the CVR during this portion of flight. Altitude callouts showed a possible lower than actual altitude understanding by the crew. To explain how we determined the helicopter's actual height above sea level, I'm going to start by walking through the altitudes recorded by the accident airplane. The CRJ recorded 3 types of altitude measurements: pressure, radio, and geometric. As discussed at the beginning of the presentation, radio altitude is measured by bouncing radio waves off the terrain below an aircraft, and geometric altitude is determined by GPS satellite triangulation. These 3 types of altitude are shown in this plot as recorded. Like pressure altitude, radio and geometric altitudes must be corrected for local effects. When these 3 independently measured altitudes were corrected for local conditions, they showed good agreement by being within 10 to 20 feet of each other, confirming they were reliable measurements of the airplane's height above sea level. After some additional checks at known ground locations, the CRJ's altitude was considered well validated. This plot shows the CRJ's corrected pressure and radio altitudes as solid lines, and the Black Hawk's corrected pressure and radio altitudes as dotted lines for the end of the flight. The Black Hawk was not broadcasting to ADS-B, so no geometric altitude was available for comparison. For the final 5 minutes of flight, the helicopter was flying over the tidal portion of the Potomac River, so the radio altitude would be equal to the height above sea level. Additionally, later testing of similar helicopters, which will be discussed next, showed good agreement between geometric and radio altitudes while over the river, adding an additional level of confidence to the radio altitude's accuracy. While the radio altitudes of the CRJ and the helicopter, which are shown as red lines, were within 10 feet at the approximate time of impact, the helicopter corrected pressure altitude was 100 feet lower than the CRJ's corrected pressure altitude. This picture shows the instrument panel of a UH-60L. On the right side of the image, the radio altimeter is circled in red, and the barometric altimeter is circled in green. The discrepancies between the radio and pressure altitudes recorded on the accident flight data recorder and questions about what altitude was displayed to the crew based on their altitude callouts led to a series of altimeter tests. 3 UH-60L helicopters from the same battalion as the accident aircraft flew a formation flight where the right seat pilots wore cameras to record the instrument panel. After the flight, the data recorders for each helicopter were downloaded for comparison to the in-cockpit instrumentation videos. This led the lead helicopter was broadcasting to ADS-B, so geometric altitude for that aircraft was also recorded. The altimeter testing found that on the ground, before the engines were started, the barometric altimeters of all 3 helicopters were within 20 to 45 feet of the field elevation, which would be considered within tolerance. Once the main rotor was producing enough lift to hover, the barometric altimeter readings dropped significantly and were lower than the helicopter's actual on-the-ground elevation or hover altitude. Notably, the barometric altimeters continued to be 80 to 130 feet lower than the helicopter's determined altitude above sea level when flying at speed over the tidal portion of the Potomac River later in the test. Additionally, the corrected pressure altitude recorded on the data recorders did not match the video captured barometric altimeter readings on the ground for any helicopter, but did show good agreement when flying over the Potomac for 2 of the helicopters. The results of the flight tests led to on-ground tests of the pitot-static systems for each helicopter. For these checks, the pitot-static probes are connected to a test rig that simulates set altitudes by increasing or decreasing the pressure the probes see. The altimeters on 2 of the test helicopters performed well. On the 3rd helicopter, the altimeters still performed within or near the tolerance, but were less accurate. So, while the altimeters showed an 80 to 130 foot differences in flight, they were within 20 to 55 feet under a controlled test environment. A helicopter's rotor system produces the lift and thrust that allows it to fly. The wind that you feel when you are near a helicopter taking off is the downwash produced by the rotor, which changes the air pressure around the fuselage of the helicopter, making it challenging to measure an accurate static pressure to determine altitude. The controlled environment of the pitot-static ground checks eliminated all rotor downwash effects, and those results also match the flight test altimeter readings that were made before the engines were started. But once the helicopter rotors were turning and producing lift and thrust, the altimeter readings lowered significantly and stayed lower throughout the flights. In summary, we found discrepancies between the FDR pressure altitude and determined height above sea level for the accident helicopter. Subsequent testing showed discrepancies between the cockpit barometric altimeters and the determined height above sea level on 3 other UH-60Ls. The objective of this panel is to learn more about the design of pitot-static systems and the altimeters, the unique challenges in designing such systems for helicopters, and how the accuracy of these systems is determined and maintained. Another objective of this panel is to learn more about how parametric data, particularly from the air data systems, are validated for flight recorders. This concludes our presentation. Mr. Shin will now begin questioning.
For the witnesses for this panel, we'll ask our questions in 3 distinct topic areas: air data system design, pilot operational considerations with the barometric altimeter, and air data accuracy for flight recorders. So we'll start with air data system design. Mr. Cooper, can you please describe some of the engineering considerations on the placement of static ports on a helicopter?
When placing the pitot and static ports on a helicopter, you must first consider the total set of customer requirements, and then consider the complex flow dynamics, as was shown in your presentation, that occur throughout the whole flight operational regime of the aircraft.
And when you say customer requirements, can you expand on that, please? What that could entail?
For example, they have where they're going to operate. So if they have to land in austere conditions, sand, grass fields, have to consider impacts to material entering the probes or damaging the probes. Must consider maintenance operations on the aircraft. If the probes are placed lower, there is risk, of course, to the maintainers, bumping injury as well as damaging the probes. And then another area that needs to be considered, what other sensors are populated on the aircraft? Those sensors have their own needs for placement to meet their performance requirements, and they can create disturbed airflow in themselves in different locations that, of course, would affect that probe location.
And Mr. Cooper, how does the location of the static port affect the cockpit instrument readings during different regimes of helicopter flight, such as hover, cruise, sideways flight, backwards flight?
It's a function of the static position error that exists in those different regimes of flight. So the helicopter has, of course, a wide operational movement, forward, rear, sideward, rearward flight, as well as side slip limits. The static port placement must be able to handle the whole regime, although accuracy is normally presented in forward flight.
And Mr. Cooper, how are the aerodynamic effects of the cockpit instrument readings due to placement of the static ports identified during the design phase for the air data system?
When this aircraft was originally designed in the late 70s, placement was done by experience and general practice. Military helicopters from Sikorsky at that time placed the probes over the cockpit and was generally found to meet the requirements. Of course, today, computational fluid dynamics could be used to analyze, but in the late 70s, that was an opportunity. So the placement is made, and then flight test is utilized to gather the data to identify the resulting error of that placement.
And is there a design target for the amount of difference between indicated altitude and the actual altitude for the helicopter when designing a system?
Can you clarify, please?
So for the difference between what's indicated in the cockpit instrument to where the helicopter is actually at for altitude, is there a target during the design phase that you try to achieve for the placement of the ports for certain airspeeds?
For the UH-60, it would be based on any government requirements.
And what about for commercial helicopters that Sikorsky has designed?
Again, it depends on the category it's being certified. FAR 291325, provides guidance for static position error, as well as it provides wording that you must use a certified altimeter.
Okay. And with the complex flow environments that we've identified that are present with helicopters in designing these systems, can you please describe some of the mitigation strategies that may be used to account for these aerodynamic effects that you see in the indicated altitude?
For the Black Hawk, at the time it was designed and with the government requirements that were provided, really probe geometry, placement, its installation angles is the primary tool. the UH-60 government requirements specified a specific altimeter to utilize. So that would not make the altimeter indication system an option to address any corrections. Present day, of course, with advanced equipment, air data computers give you more of an option. But again, 1970s, late 70s, that was not available, and the government requirements specifically called out the altimeter to be used, and it was provided as government furnished material property.
And Mr. Bradham, how would the Army evaluate mitigation strategies developed by a manufacturer?
Yeah, so typically in flight test, but if I could just back up for 1 second and just to clarify, so for a pedostatic system, we talk about instrument error, which is the actual calibration error in the physical altimeter itself, and that's what you're checking when you check on the ground without the rotors turning. And then you have what is called position error or installation error, which is the error caused by aerodynamic effects around the aircraft. And those are two independent errors with different standards. And I would say the standards that the Army used and the standards that the FAA uses for civil aircraft are very similar, and these issues are not unique to military aircraft. But your question is how would we evaluate that? And you do an airspeed calibration in flight test, and that airspeed calibration determines, for a given flight condition, determines the position error of the pedostatic system, and then we can mathematically convert that into altimeter error, and we can assess that against a standard. So for the Black Hawk, the position error, that standard was a mil spec called MIL-I 6115, which has a very similar, slightly more stringent standard than Part 29.
And if a helicopter did not meet that military standard, would there be a required redesign, or would there be a correction factor that gets applied that pilots have to utilize? This question is to Mr. Bradham.
Yes, I think that would depend very much on the specific circumstances. There were, looking back through the historical documents, there were cases where there were small out of spec issues. One not over a standard in one place, and the decision is made, by the government and the contractor that there's no further action required there. They can provide a correction to the operator when that's necessary, but again, I think it would depend on the particular flight condition and the particular size of and the effect of the noncompliance.
Mr. Cooper, for the UH-60L helicopter, the pedostatic probes are placed above the cockpit, which is closer in proximity to the main rotor. What are the technical considerations that would lead for those pedostatic probes to be placed closer to the main rotor?
In line what I stated before, it's a balance of the total set of requirements. So again, for a military utility helicopter operating in the landing conditions it does, placement of the probes lower, as I said, could expose it to ingress of material, danger to maintainers, damage during ground operations. So that would tend to give guidance, provide an alternative by putting it above the cockpit, as was done on other military models, Sikorsky and others produced at that time.
And Mr. Gant, can you describe how the FAA approaches certification of static systems and barometric altimeters on civil helicopters?
Yeah, so as mentioned previously, for altimeters in civil transport category helicopters, that is regulated by Federal Aviation Regulation 29.1325 for altimeters. And the expectation is that the applicant for certification would comply with all the requirements within that paragraph, including the position error requirements that are in there. There are allowable tolerances.
And from the FAA's perspective, would there be a concern with the placement of the pedostatic probes as seen on the Black Hawk?
I don't have any opinion on that. I think there's different ways to design, just as you've shown in your presentation. Maybe typical today is more on static port locations on the fuselage, but there have been many instances where static ports are also co-located with the pedo system. So again, it comes down with compliance to the requirements and not necessarily the aspects of whether that's incorporated one way or the other.
And Mr. Cooper, aside from customer requirements, what would be other technical considerations to select a pedostatic probe versus a pedo probe with a separate static port that's on the fuselage?
Again, I sorry to come back to it, but it is the total set of requirements. In that picture you showed for the fuselage placement, that was a Naval Hawk aircraft, a Sikorsky produced Naval Hawk aircraft, but it does not have a requirement for a sliding cabin, or also known as the gunner's window. So that area would be covered when the gunner's window is in the open position, as it can be in flight. So that would take that location, that example you've shown. It comes down to available real estate, the dynamic conditions in that area. In your discussions with me earlier, you mentioned tail ports, static ports, but again, there's equipment on the Black Hawk that would impact that operation. So it's considering all the requirements that the helicopter must meet, what's fitted to achieve that, and what available area on the fuselage can be utilized, and then with that, understanding the dynamic conditions that may be present on that fuselage if it's static, if it's suitable for a static port.
And Mr. Bradham, aside from the static 1 and static 2 systems on the Black Hawk, are there alternate static sources?
No, not on the Black Hawk. The S1 and S2 are redundant, and each static system, as you mentioned in your presentation, pulls from each side's pitot tube. So S1's fed from both right and left, and S2's fed from both right and left.
Okay. Can you please, Mr. Cooper, this question's for you. Can you please describe the types of errors that can add up to ultimately affect the indicated altitude on the barometric altimeter?
As was stated by the other gentleman, there's two prime areas. One of them has several contributions, but there's the static source error, and then there is the instrument error. The instrument error for this altimeter has several factors that builds up to its estimated error. Instrument error, consider a tolerance. There's a plus and minus. So when you come up with that error, there could be in the plus direction or the minus. Static source error, which is identified, the resulting is identified during flight test. It's usually a number as a function of airspeed, and it is not constant, but I would not call it a tolerance. There's not a plus or minus. There is a number that's identified during flight test as a function of airspeed.
And Mr. Bradham, from the airworthiness perspective, how are the stack up of these errors managed by the Army?
So for the, from an airworthiness perspective, right, we have standards for each of the individual errors as they occur. So instrument error, so for the altimeter itself was handled for the Black Hawk by mil spec. It was a mil spec, it was 81852 and 81851, and that lays out a number of individual tests under specific conditions for a number of specific errors. So for example, inside the altimeter, there's two separate calibration tests, one for the Colesman window gearing and one for the expanding aneroid capsules. And there's different standards for those, and those are independent errors. So we don't have a standard to roll all that together. We do it by each individual error that occurs to make sure it meets tolerance. And I believe that's how it's done, not just in the Army. But then you have position error, and as I said, that's a mil-spec 6115 alpha, which has a standard for that. So, and then, yeah, so that's how we manage it. Each one of the errors has its own tolerance defined. And there's corresponding civil standards. The FAA has a TSO, a technical standard order, that defines altimeter instrument error, and FAR Part 29 talks about altimeter position error, same as the mil-specs used to.
Mr. Cooper, can you tell me about other designs for barometric altimeters? In this case, the accident helicopter's barometric altimeters uses aneroid wafers or capsules, as Mr. Bradham mentioned. Can you tell me more about other designs that ultimately allow for higher precision and accuracy for barometric altitude or pressure altitude?
So first, the time period, that was a common design. And as I said, in the government requirements, that altimeter was specified to be used and was provided by the government. As time has gone on, and certainly current day, air data computers became available, which provided they did not have the mechanical wafers, the mechanical indicating dial. They did not have the mechanical correction for the Colesman window. So those errors could come out. So the implementation of air data computer, which requires a different display medium, allows you to achieve a lower error at the instrument error analogy.
And Mr. Bradham, what are the factors that are considered in transitioning existing helicopters to newer technologies such that Mr. Cooper just talked about?
From an airworthiness perspective, we're just looking to see if it meets all the standard requirements. I would say that, the Army and DoD, we've moved away from the very prescriptive mil specs, and we use commercial standards more typically going forward.
And Mr. Gant, from the civil helicopter side, at what point do the design requirements warrant transition to newer technologies that we're talking about here with air data computers?
Well, we don't prescribe when a new technology has to be introduced unless it's one that we think would improve safety to the extent that we would go through the whole process of rulemaking to make that technology available, or a requirement, excuse me, in the federal regulations.
And Mr. Gant, would changing operational requirements in the national airspace key into that decision of whether rulemaking is needed to require newer technologies?
I would say it could factor into that.
And this question is for both Mr. Cooper and Mr. Bradham. Aside from rotor wash considerations, what other challenges are there in designing an air data system that provides accurate indicated altitude to the pilots?
I go from my perspective, the main issue is low speed operation, right? And that's the influence of the rotor wake, which is what you talked about, right? It's why you see, when an aircraft picks up to a hover, why you see the altimeter decrease, right? It's the rotor wake coming down on the static system, and that's at low speeds, common to helicopters, that can be an issue. It's why the Black Hawk pressure instruments, really below 40 knots aren't used. So I think that's the primary issue, but the configuration of the aircraft can affect the static position error.
Yeah, for low speed, it is obviously the rotor wash, but at more forward speeds, that rotor wash is not impinging on the probe, so that is not a factor at the higher speeds. Certainly above 60 knots normally is where we don't see that effect. Again, depends on the install, but it is the configuration of the aircraft, what else is installed, either originally or as the model has been utilized, and certainly the customer has updated configuration of the aircraft. So installation of items can have an effect on the static position error.
Thank you. I'll hand it off to Ms. Mueller.
Good morning. Mrs. Lewis, when flying at low altitudes, do you normally reference the radio or the barometric altimeters?
In my experience, when flying at low altitude, I would be referencing the radar altimeter.
And when would you transition roughly between the two?
In my experience, certainly 200 feet and below, I would be referencing the radar altimeter. However, if I was flying on a published MSL route, I would be referencing barometric altitude.
Ms. Lewis, can you go over the procedure for setting up the barometric altimeter and checking it before flight?
Yes, as part of the cockpit equipment checks, the barometric altimeters are set on the ground before the aircraft is started, and the requirement for the Army is that they are within 70 feet of field elevation.
And where do you get the barometric setting from, usually?
From ATIS, the Automated Terminal Information System.
Thank you. Mrs. Lewis, what reason might you flag your barometric altimeter as being inaccurate?
Aside from the initial check on the ground, in my experience, the only reason I would have to question my altimeter would be if ATC were to call me and question what altitude I was flying at, if I was supposed to be flying at an assigned altitude or on a route at a particular altitude.
Okay. So moving gears a little, Ms. Lewis, what other helicopters have you flown?
I have flown the Alpha, Lima, Mike, and Victor versions of the Black Hawk, and those are the only helicopters that I have flown.
Okay, thank you. So on those other models, have you seen any differences between the Lima model and those helicopters for the barometric altimeter?
Can you clarify the question, please?
Okay, so when you're at hover in that flight regime, have you seen between like the Alpha to the Victor and the Limas different, like do they feel different? Like what is being displayed on the barometric altimeter?
In my experience, I'm not referencing the barometric altimeter to hover. I would be glancing inside at the radar altimeter while at a hover. I would not be paying much attention to the barometric altimeter to hover.
Okay, thank you. Mr. Bradham, could you please describe the standards related to the design of the static system for the Army helicopters?
Yeah, absolutely. And I think it's important, of course, to point out again that the standards are very similar between military and civil, particularly the ones used for the Black Hawk. And so we'll talk about all the different kinds of error, right? So the standards, you have a standard for the instrument itself, which was the mil-spec 81851 and 81852, which have the same tolerance. And that has a number of different tests inside it, a number of dynamic tests for things like hysteresis and friction. But I think the main ones to focus on here are the two calibration tests. You have a scale error test, which is where you test the calibration of the capsules themselves. Mm-hmm. And then you have a barometric scale setting test where you test the calibration of the Colesman window gearing itself. So you have standards for each one of those, and those standards vary by temperature and they vary by altitude. So for example, in the scale test, The standard at sea level, standard temperature is plus or minus 30 feet. But at 500 feet, that's plus or minus 35 feet. It changes. At extreme temperature, that can go to as far as 60 feet. And then the barometric scale setting is generally plus or minus 25 feet, but it too changes. And that's very similar to the FAA TSO, which is based on a Society of Automotive Engineers standard. And then you have the position error standard. As we talked about, that's for aerodynamic effects on the system. And that's, in this case, that was from MIL I 6115, which is plus or minus 25 feet per 100 knots of airspeed. And that's very similar to Part 29, which is 30 feet per 100 knots of airspeed. And then I'll just mention it here, just that if you compare radar altimeter to baro altimeter, you have to keep in mind that radar's measuring true altitude, like if you put a tape measure out the aircraft to the ground. Pressure altitude is measuring a pressure altitude based on a temperature assumption, and so you have to correct for non-standard temperature as well. Thank you.
Thank you. So, Mr. Cooper, what amount of difference between the barometric altimeter and the helicopter's actual height is expected for UH-60L?
Based in my review of the government requirements prime item development spec, I've not found a standard cited for static position error, not defined. Instrument error is identified by the MIL specs that were cited, 81852 and 8851. The MIL spec that was cited, 6115A, was identified in a report, but have not found it defined in the government requirements. So ultimately, the resulting error was identified by flight test.
So those identified by flight tests, and we've kind of already talked about this a little bit, but the error changes at different regimes, in different flight regimes.
So yes, the flight test data is presented as altitude error as a function of airspeed. So it is not necessarily constant number. And as in the report for the UH-60 Alpha, which the configuration is the same for the Lima, it is changing for the clean configuration, so I can't give you a singular number. For the configuration, it's called high drag. It's when the external storage support system, also called ESSS, and we often, at least in Sikorsky, call it ESSS, so there's a lot of acronyms used there in case I say it again. That also has a different static source error curve. That one is more consistent, though, and is a nominal above, I believe, 40 knots is a nominal 50 foot. I'll have to check on the speed, but it is, as you stated before, as is the clean, higher in a hover, but in forward flight, it's a nominal 50 in that configuration.
Thank you. Oh, and just for people who are listening, the ESSS, or the picture of the accident helicopter, the wing tanks out the side. Right. So how does Sikorsky manage that difference in altitude? What is it that you produce for the operator and the crew?
So the flight manual is approved by the Army. Its content is that which is approved by the Army. In the report of the test I cited, in that document, it recommended that the curves for the altitude position error for the clean, as well as the high drag external storage support system, be included in the flight manual, but it ultimately was not included in the approved version.
Thank you. So, Mr. Bradham, Mr. Cooper was just saying about how the flight manual discusses the differences for the clean configuration helicopter, but it didn't make it into the Army flight manual, the differences for the ESSS system.
I'm sorry, just clarification, both altitude errors are
Both
not
sets
in the
of
final.
altitude
Yeah,
errors,
just
sorry.
for clarification.
Do we believe that crews should be informed of this difference?
So for the external store support system for ESSS, yeah, that level of position error between 80 knots and 100 knots of about 40 to 50 feet, that level of position error was identified, you know, in the original qualification of the system. We verified that level of error exists through the L. We've looked for records of the discussion. At the time, there would have been an operator's manual content review board, and we've looked for a record of the discussion about altitude. We've not found a record of a discussion about whether, you know, about a decision to include or exclude that information. I think it's important to put that information in context when you're thinking about what to provide to an aviator in particular error has no influence. Spec, and you know, in my experience, typical aircraft separation distances are 500 feet or more. So it would be, I'd be speculating if I went to the reason of why I put that in record.
Now that it's been identified, do you plan on including it?
I would say we've been tasked by the program, the Airworthiness Authority has been tasked by the Program Office for Utility Helicopters to do the analysis, which we've done, and to provide a recommendation back, which is being done right now, which will then go to the PM office for their consideration as to how to whether and how to incorporate it into the manual.
Thank you.
Thank you.
Mr. Bradham, do you have the time frame for when that will be completed?
No, I can't speak to the program office in terms of the timeline. We've been.
Steve, or Mr. Bradham, I can speak to that.
Thank you.
I'm the Division Chief of the Utility Helicopter Programs Office. I was the one who tasked Mr. Bradham's organization to take a look at this issue. And so typically we have a 30-day turnaround on tasks to the organization. We're about week 2 of that. And that's about the time we found out about this issue. And so we should have something back this fall at the latest. And we'd be happy to keep you appraised of that status.
Thank you. And I also ask that you bring your mic closer to you. Thank you.
Will do.
All right, Ms. Lewis, during our investigation, we saw the 80 to 130 foot differences between the barometric altimeters and then the radio and the geometric altitudes. Would you, as a pilot, consider this amount of difference impactful to your operation?
In my experience, a difference in 80 feet or so between the radar altitude and the barometric altitude would not be cause for alarm. Generally, I'm relying more heavily on one altitude instrument versus the other, depending on what I'm doing and what altitude I'm at. So I'm generally not looking at both and trying to figure out the difference between the two, depending on what I'm doing on that particular flight.
All right, this is for Mr. Cooper, Bradham, and Rosengren, just to start. But during the ground testing of the 12th Battalion helicopters, 2 of the helicopters, the barometric altimeters were within 20 feet of tolerance. But once we were in forward flight, 100 knot, with 100 knots of forward speed, the barometric altimeters showed errors of 80 to 130 feet. What types of errors do you believe could contribute to this 80 to 130 foot discrepancy?
Yeah, I'll start with that one, please. So when you think about all the different errors that could contribute to that, one, you have to make sure the Colesman window is clearly set correctly, and that the Colesman window actually reflects the actually reflects the right barometric pressure. So the flight tests you're referring to are the ones on the 15th of May, that 1-unit flight. So backing up, it's important to point out that that's really an anecdotal event. It doesn't use the standard flight test methods that the military and the FAA would use in order to characterize a pedostatic system. So there's not an independent truth measurement of barometric pressure and some of the other things that we would use here. But so in terms of the errors, one is the Colsman window. Then you have the instrument error, which is what you saw on the ground. All 3 of those aircraft were registering altimeter low on the ground, but within spec, right, for the instrument error. Then you have the position error. So 2 of the aircraft were clean, and 1 of the aircraft was ESSS. So the clean aircraft at 100 knots, you're looking at about roughly 7 feet altimeter low in position error. For the ESSS aircraft, about 50 feet position altimeter low for position error. And then you also have to correct for non-standard temperature because you're trying to compare radar altimeter to barometric altimeter. And so that wasn't a factor for the accident aircraft because the conditions were close to standard and you were low altitude. But on the 15th of May, those flights, you were flying at about 1,000 feet and about 9 degrees hotter than standard based on the aircraft OAT. That's about 36 feet altimeter low. So the combination of those factors, the instrument error, the position error, and a temperature correction, which all happen to be in the same direction, doesn't always happen that way, but in this particular case did, that if you carry that for the 3 aircraft, those errors ends up bringing you to relatively good agreement between rat out and bear out, if you compare them that way.
Thank you.
And I concur with all the statements that were made. Just one clarification, because I was involved in that ground evaluation. One of the aircraft, the right altimeter, did fall outside the Army maintenance manual check limit, so that was out of spec, and in fact, its vibrator was inoperative. So that right altimeter data would be in question for that aircraft.
Thank you. Mr. Rosengren, do you have anything to add?
No, I just, the only comment I have there is whenever Mr. Bradham and I kind of went through the data, pursuant to some of the questions I think we'll have later, I was properly educated and pleasantly surprised. We was able to get to doing the air stack ups within 1 foot of the differences, and so we'd be happy to provide that data to you in writing later.
We would definitely appreciate that. Thank you.
Yes, ma'am.
So continuing on that, and you were talking about how it is anecdotal, and we do recognize that 3 helicopters is quite a small data, it's a very small sample set, but it did line up with the existence of a possible wider discrepancy. And you have looked into that, clearly. Is there additional testing planned between the Army and Sikorsky?
So from an airworthiness perspective, we've gone back through the data, and we have airspeed calibration data for the Lima. We understand the static position error. So we don't have any flight testing planned. I'd leave that to the program office if they have other thoughts relative to that.
Yeah, no, as I mentioned earlier, I was as initial receipt of the data from the flight test and anecdotal flight test you mentioned, I wanted to look into it, and I asked Mr. Bradham's organization to please let's get together and try to understand what's going on here to see if there is an issue. And again, after stepping through all of the various sources of error, and again, it's a very piece-part manner, everything was within specification minus the discrepancy we've tasked them to look into. And so I don't see any need from a safety or airworthiness perspective to do any changes for the Lima helicopter. From my perspective, I advise the colonel who advises the Army the safety of the aircraft. My perspective is this is a safe aircraft.
Yeah, and we can, if you'd like, we can talk to the difference between the recorded pressure altitude in the recorder. Yeah. Oh, cool. Thank you.
So this conversation makes me conclude that this feels like this is an inherent limitation of a barometric altimeter.
That based on all the information we've worked together and along with our Sikorsky friends, I believe this is the expected errors in an altimeter system. So when we provide that data to an aircrew, there should be an expectation, as I believe they're trained to have that expectation, plus minus 100 feet or so.
Thank you very much. This is the end of my line of questioning, and Mr. Payne will begin next.
Get my microphone positioned here. Hello. I'm going to follow on with specifically pilot operational considerations, and we talked a bit more about stacking errors, and we touched upon setting the Colesman window correctly. I'm going to come back to that. So I'll start with Ms. Lewis, and I'll have some questions for Mr. Bradham also later, as he's an experienced Black Hawk pilot, it's my understanding. Ms. Lewis, earlier you described briefly setting the altimeter, your operations around that area. As a pilot, can you walk us through in detail the process of setting the altimeter according to the Army's operational procedures?
Yes, as part of the cockpit equipment checks, the barometric altimeters are set generally based off of the local ATIS information, and then it's compared to the known field elevation. And as long as there's not more than a 70-foot error, then the altimeter is considered reliable for flight.
Sure. I want to get into a bit of a discussion about the known field elevation. So you cross-check, obviously. Once you've set the altimeter according to the ATIS, there's a 70-foot allowance. My next question goes into, how do you determine the field elevation for those who are unfamiliar in the audience? Where do you get that data from?
Field elevation is published on airport diagrams. It's published on approach place. It's published in a number of places for airports that we operate in and out of.
Sure, for operational airports. So continuing on with maybe where your unit was based, is it tribal knowledge or an official part of Army procedures to discuss if there's changes in elevation between where the measurement is taken, which for FAA airports typically at the highest point on the runway, if you're starting or performing that check, as you said, prior to rotors turning, are you do the Army's procedures account for a difference in the airport topography when you make that check and try to fall within the 70 feet?
The Army procedure is to check tower setting against the setting for field elevation, and that it's unreliable for flight if more than 70-foot error exists.
Sure, okay. Can you recall a circumstance where the published field elevation varied significantly from where you initiated the checklist procedure in your career?
As part of the checklist procedure, we don't attempt to determine if the elevation is different based on where the aircraft is parked. We base it off of the field elevation.
Okay. I'm just going to we talked about field elevation being published at FAA or, some kind of, whether in another country there's published data available. What if you're at a remote or unfamiliar airfield, you're operating there? Is there another resource you might use other than published chart, or would you rely on the topography of the chart itself in that situation?
I would rely on the known field elevation if there was one for where I was landing and taking off from. And in my experience, I would have generally departed from somewhere where I had an altimeter setting. And if I did not know what the field elevation was or was unable to determine it, I would maintain that altimeter setting until I was back in location to receive an updated altimeter setting.
Okay, noted. Yeah, I'm just trying to approach the situation from as many angles as possible. When you're flying in the national airspace system versus flying on deployment outside of the national airspace system, for example, do these procedures change at all, or there's more emphasis done in the NAS versus on deployment, or does it remain the same?
There's no difference in how we approach setting altimeters when we're operating in the national airspace system versus on a deployment.
Okay, Thank you. I'm going to incorporate Mr. Bradham into this line of questioning as well, so I just want to totally lean on Mrs. Lewis. So, Mr. Bradham, during flight, how would a pilot determine the barometric altimeter is erroneous and unreliable?
Yeah, so in my experience, the only time we've done that in flight right on the ground check, if you had a significant difference, between the right and the left side in the ground check before you took off. And I want to point out that ground check exists. The FAA uses that same, in the Airman Information Manual, uses a similar check with plus or minus 75 feet. But yes, and in flight again, if there was a significant disparity between the right and left side while you were flying, and I mean a significant disparity, more than 70, 80 feet, right? You would make note of that and come back. But if ATC contacted the aircraft and said, hey, you're not at your right altitude, and we were, according to our instruments, that then would be cause for concern. But otherwise, and I've, in my experience, I'm trying to recall if that's ever happened to me where I've had a barometric altimeter problem like that, and I don't recall one.
Okay. Yeah, Ms. Lewis, you previously mentioned being queried by ATC. Have you ever experienced that in your career, or thought to a situation where you might want to question whether or not the left and right side altimeters were comparable?
I have not had an experience in my career flying the Black Hawk where the barometric altimeter, if it passed the checks on the ground, was unreliable.
Okay, thank you. Let's say hypothetically you had a crew and the two pilots did detect an offset between the right and left baro altimeters. I'll start with Ms. Lewis. What would they do? And then as a follow-up, would there be anything in the Army's operational procedures that would require the pilots to make a report or report it to maintenance?
If there was a discrepancy between the left and the right pilot's altimeter, are you asking which altimeter we would use?
Well, no, not which you would use, but you've detected this discrepancy. It's more than 70 feet. Is there a requirement to report that then to maintenance, your command, make a note of it somewhere?
Yes, if there was a greater than 70-foot difference, that aircraft would not be flown. It would be placed on a grounding red X condition and be taken out of service until the altitude discrepancy was addressed.
Okay. I'm going to come back to this question, and you touched on it previously, but you said you preferred a different altimeter for different type of operation, different flight regime. In Army procedures, is there ever an operational area where you would cross-check between the barometric altimeter and the radar altimeter?
In my experience, in a situation where I was flying close to the ground, maybe 500 feet and below, if I was supposed to be at an MSL altitude, but I was flying low to the ground, in my experience, I would be referencing or cross-checking both instruments in that situation.
Okay. I understand it would be difficult because it would depend on where you're operating. If you're over sea level, obviously that calculation's much easier. Getting more into a bit of an acuity discussion, so it's discussed in our internal investigation. If you're flying in visual conditions during the day, what would the altitude visually that the pilot could recognize, would 100 feet difference be something that pilots are trained to know visually without reference to any instruments versus maybe 1,000 feet? Mr. Bradham or Ms. Lewis can take that.
Yeah, I'll give my experience.
Yeah.
And when you're very low to the ground, that's true, right? To be able to tell the difference between 100 feet and 200 feet, I would say yes. But, you know, at a much higher altitude than, you know, the difference between 4,000 feet and 4,100 feet, no.
Right. Yeah, exactly. If you're at higher altitude, also you can maybe tell difference of thousands versus lower. Let's see. Would this change at night? If you were, you know, low-level flight, you say, oh, I can tell the difference between 100 and 200 feet at night. Would you expect that calculation to be the same? I'll ask Ms. Lewis.
It's always more difficult to determine your altitude when flying at night, but I agree with what Mr. Bradham said, that if you're very low level, 200 feet and below, it's a little bit easier to determine, but even at 1,000 feet, 100 feet of difference is not something that in my experience, that I'd be able to accurately determine.
Sure, and then a quick follow-up there. If you're wearing night vision goggles, I guess, can you expand on the possibility of doing that under NVG at low level?
NVG's low level, if I have, it would help if there were known obstacles that I knew the height of as I was flying in the area out to the left and right of the aircraft. It really depends on what environment I'm flying in, what obstacles are there, buildings. It would really just depend on where you were flying out, how easy it was to determine a difference in 100 feet of altitude when looking outside the aircraft.
Okay.
Yeah. Can I intercede real quick?
Yeah, go ahead.
Just to follow up on Mr. Payne's question, for both Mrs. Lewis and Mr. Bradham, if you were flying in day visual conditions, could you notice a difference between flying at 200 feet versus 300 feet?
That's a difficult question to answer. From my experience, I would have to say that would depend very much on the terrain that was around and how familiar I was with that terrain.
I would agree with that statement. It would depend on where I was flying, and as I mentioned previously, if I knew the height of some of the obstacles or perhaps building or terrain in the area.
So to clarify, if you were not familiar with the terrain that you were flying through, then what does the answer change?
Can you just restate the question once just to make sure
If you're not familiar with the terrain you're flying through, could you pick up on a difference visually looking out the window between flying at 200 feet versus 300 feet? Is there enough of a difference at those altitudes?
Yeah, that's a difficult question to answer. I'm not sure if you'd be able to resolve that difference.
I agree. I don't know that I could 100% accurately determine the difference in altitude.
And my question was for day, so just to confirm my understanding, at night and under NVGs, it would be even more difficult to make that distinction?
Yes.
Thank you.
That was my kind of operations-related section. I'm going to shift gears slightly for my last few to Mr. Cooper, discussing some differences between the Mike and Lima model. So, Mr. Cooper, please describe the pedostatic system design on the Mike model.
Do you want to explain what the Mike model is versus Lima?
Sorry, for the audience, the Mike model would be a newer version of the helicopter. If you want to just expand on that rather than me explain why don't we just talk about the differences as well?
Again, it has its own set of requirements, to their vehicle, different engines, different, more capable rotor blades. So, but from an air data system, it utilizes the same pedostatic probes in the same location as the Lima. That is unchanged. It employs air data computers, ATCs. There is less plumbing because there are no, I will call them analog instruments equivalent to what is in the Alpha or Lima. So those probes feed directly Yeah, they feed the air data computers. The air data computers feed multi-function displays with digital data. So they're, and then those same ADCs through a redundant path provides air data information to the flight controls or any other subsystems within the aircraft which needs that information. There are two ADCs. Each go to the their respective pitot probe, and the static, just as with the Alpha and Lima, is crossed. So there's the redundancy there.
Okay, so in summary, you've replaced, you said, well, older analog digital systems, there's less tubing because you have two ADCs and a glass panel display. I guess my ultimate question would be, given the differences between the Lima and the Mike, would you expect more accuracy out of the Mike versus the Lima in terms of displayed altitude?
Again, we talked about static source error and instrument error. I would expect improved accuracy for the instrument error aspect. The static source error is not changed.
Thank you. I'm going to pass the microphone over to Michael Portman, aerospace engineer from the Flight Recorders Lab. He's going to discuss air data accuracy for flight recorders.
Thank you very much. All right, good morning. So yes, as Mr. Payne mentioned, I'm going to start my questions with some design requirement questions for flight recorders. So I'll start with Mr. Gant on the civil side. What requirements exist for flight recorders in civil helicopters?
So for flight data recorders, there's a requirement in Part 91, which are the general operating rules, that if you are operating a multi-engine turbine-powered helicopter with a seating or passenger capacity of 10 or more, you must have a flight data recorder that records the parameters that are contained in an appendix. I think it's Appendix E, but of Part 91 that lists all the parameters as well as the accuracy requirements for those parameters.
Okay, and that was for Part 91. Are there equivalents in other operating parts as well?
Yeah, Part 135 has a very similar requirement for, again, multi-engine turbine air-powered helicopters with 10 or more passenger seating capacity. There's another break if you have a helicopter that carries 20 or more. There's a different FDR requirement, but still one.
Okay. Can you expand for a moment on, you mentioned that included in these appendices, there's also standards for accuracy of the data. Can you expand on that a little bit, specifically if you know anything about the altitude data?
Yeah, I think in the Part 91 Appendix E, I'll say the standards, as I read them, are fairly loose. I mean, for accuracy for the altimeter, I think it reads from anywhere from plus or minus 100 to up to plus or minus 750 feet with a resolution of, I can't remember, either 130 feet or 150 feet on readout.
Thank you. One more question for you, Mr. Gant. What methods does the FAA require to ensure the continued accuracy of recorded flight data?
Yeah, so there's no specific rule that says how often you need to be, I'll say, interrogating a installed FDR to see if it's still providing realistic data. However, in the technical standard order, as well as in our advisory material, it is incumbent upon either the manufacturer of the FDR or the installer to come up with a maintenance program. And then our recommendation in the advisory material and AC 21-141B is that a reasonableness check for the FDR should not exceed being done beyond 18 months.
Okay, thank you very much. turning to Mr. Rosengren. So looking at the design of the flight recorder system on the UH-60L, it's my understanding that the system was added after the initial production of the UH-60L. Can you just explain a little bit about when that occurred and what the motivation was for installing that system?
Yes, sir. So it was we call it a commercial off-the-shelf or COTS solution that we bought for the Integrated Vehicle Health Monitoring System, IVHMS. It included both a health and usage monitoring system, so a PCMCA card that a data card, I can't tell you what PCMCA stands for, a data card that you could pull out and download the parametric data that's also sent to the flight data recorder that we used for accident investigation, such as this. And so that IVHMS, the Integrated Vehicle Health Monitoring System, produces COTS. It was around the mid-2000s. So in 2005 and 6 is when we consulted with our who we purchased this. Component and DO-178 were considered to make sure that and so when we did the modification work, we got an airworthiness release from the Airworthiness Authority, the modification work order to and then before we went through the installation.
Okay, and then I'll follow up specifically on the parametric data side of things. Did you have any standards or ideas that you had for what sort of things you wanted to be recorded, or what accuracy you wanted those things to be recorded with?
So the main reason we were putting the system on was twofold. It was for the health and usage monitoring system, which as the gentleman referred to, is our maintenance program that we use. So we download those parametric data after each flight or weekly. And we take a look at the data, make sure it mainly there for regime recognition. So by regime recognition, that's where we try to determine how the aircraft was flown, so that if we have any particular parts lives that are depending on how aggressive or non-aggressive you fly the aircraft is dependent, then we can determine that from the parametric data that regime was in, and then we can decrement the parts lives appropriately.
Thank you. Next question. Which standards, or are there standards that exist that the Army uses or requires for the accuracy of the recorded flight data on the UH-60L?
So we had a digital source collector operation requirements document back from 1996. We'd be happy to provide that if we haven't done that already. And in that standard, it was encouraged to have a commercial off-the-shelf solution, for which we did. So we didn't give the vendor we bought the commercial off-the-shelf solution from a data accuracy requirement. We need to make sure that since it was commercial off the shelf, we made sure that it met the airworthiness requirements, but that it was capable to do the health and usage monitoring system requirement, as well as the flight data recorder function.
Thank you. Can you describe how the Army verifies the function and accuracy of the flight recorder upon installation?
Yeah, so at the end of the modification work order, there's a maintenance test flight that's performed. And as that maintenance test flight is performed, we have a maintenance operations check and MOC. And in that MOC, we record what the displayed altitude or other parametric parameters are. Select not all, but select some. I'd be happy to provide that table to you. And then we record what was recorded in the parametric data.
All right, and then a follow-up to that. Can you describe similar thing, how the Army ensures the continued function and accuracy of the flight recorder in operation?
Sure. So as I mentioned, each time the particular installation has occurred, we do those maintenance test flights and we do the MOCs to make sure that the installation was successful. As we improve the system over time, We went through a substantial upgrade back in 2008, where the original 2005 system did not have an integrated flight data recorder. So the 2008 version, we put the integrated flight data recorder, of which we have the configuration today. We've had several software upgrades. During each software upgrade, they do a system integration lab test at the factory to make sure that the software performs as designed. And then we go through a similar airworthiness analysis of the MWO with the updated software. And then that MWO is then updated. And again, each time it's installed, we do the maintenance test flight and then do the maintenance operation check at the end to make sure that the data is correct.
And just to clarify, are there any requirements for downloads at certain times specifically to verify the function and accuracy of the recorded data itself?
So we download the data at the end of each flight. It's available for download and put into our data warehouse that we monitor through artificial intelligence and other means to make sure that the data is reasonable, and so that's performed on a regular basis.
And is that specifically for you mentioned for doing usage and vibration analysis and whatnot? Is that specifically for that, or is it to look at a broad spectrum of parameters?
Yeah, there's three specific parameters we look at. I can get to those particular parts, but there's three specific parameters we look at to make sure that the vibration data is not over any exceedances. And if those particular parameters are over exceedances, then we do an on-condition change to those parts.
All right, thank you. Moving on to some operational questions, although I am going to stick with you, Mr. Rosengren.
Yes,
how is the flight recorder data used within the Army? I know you'd mentioned that it's mostly used for this vibration analysis. Is there any other example of, or any times that you can think of where download of the FDR data or the flight recorder data of any type has been performed for reasons other than those you had mentioned?
In the operational Army, there has been programs over the years where we try to do a flight operations quality assurance type of effort. So those efforts have been done where we've used the downloaded data to do flight recreations, mission rehearsals, those sorts of things, but that never got out to the operational Army.
Okay. Can you describe how the data is downloaded?
Sure, there's the data card that gets pulled out of the system, and then that's taken to an aircraft notebook, a laptop computer, and you input into the laptop computer, and then there's a procedure to extract the files and get it into the cloud-based system where we store our data.
Another question for you. When looking through the data, we did notice that that there is no GPS global positioning system data that is recorded on the flight recorder. Can you just explain why that is?
Yeah, as was mentioned before, the 60 Liam is an analog aircraft, and so when we did the modification work order and the installation to put the system on the aircraft, the signals that were available, and those signals were not available for incorporation into the integrated vehicle health monitoring system.
Thank you. One last question as I'm wrapping up, this time for Mrs. Lewis. On the UH-60L, the air data transducer provides pressure altitude information to the heads-up display. I'm curious, in your experience, have you ever done a cross-check while using the heads-up display between that altitude and the altitude that's in the barometric altimeter?
Sir, in my experience, using the heads-up display would be for low-level flight under night vision goggles, and I would not be referencing barometric altitude in my heads-up display.
All right, thank you very much. I'll turn it back over to Mr. Shin.
Mr. Fuchs, can you pull up Exhibit 7 Kilo Juliet, page 23? For the witnesses, that's the presentation backup slides that has the diagram for the right barometric altimeter and the uncorrected pressure altitude that it feeds to the helicopter's transponder for the UH-60L, and how that pressure altitude data gets transmitted to ATC ground radar and also out to ADSB. So, Mr. Bradham, on this on the UH-60L, if the right barometric altimeter provided inaccurate altitude indications, regardless of the source of the error, would the transponder transmit that inaccurate pressure altitude through the to ground stations?
Yeah, so the transponder on the right side has an encoder, and the encoder sends a signal in 100-foot increments, and that signal is based on pressure altitude, so it's referenced to 2992 as the Colesman window. So if the pilot made a mistake and put the wrong Colesman window setting in, or the setting was not indicative of the true static pressure, that error would not be transmitted. But any other errors in the system would be transmitted. But the encoder is transmitted in, it's only in 100-foot increments. So, yeah. Cool. Thank you.
And Mrs. Lewis, for the UH-60L, are there procedures for what pilots should do with the transponder's functions if they detect that the right barometric altimeter has become unreliable during flight?
For the UH-60 Lima, the transponder is required for flight. So if there was an issue with the transponder, the aircraft would return to whatever station it departed from, and that issue would be addressed before flight was continued with that aircraft.
I'm sorry, if I may, could I just add one point that the encoder, it's sending in 100-foot increments. It changes at the 50-foot mark, but the standard is at the 50-foot mark plus or minus 40 feet. So it can be 90 feet off inside its specification. Thank you.
And Mrs. Lewis, to clarify, if the right barometric altimeter was determined to be unreliable during the flight, knowing that it transmits its encoded altitude to the transponder, is there any procedures to disable the altitude reporting function on the transponder, or do you just leave it alone?
There's no published procedure for addressing that I'm aware of.
And would you notify ATC of the discrepancy that's identified if flying in the National Airspace System?
I would.
Mrs. Lewis, going back to one of the previous questions about cross-checking between the left and right altimeters, and this is a question that Mr. Bradham can answer as well. Is there a published procedure for pilots to cross-check between the left and right side for accuracy between the two altimeters?
The check is against field elevation. It's not between the two altimeters. So the 70-foot error, if field elevation was 0 feet, one could be 70 feet and the other one could show minus 70 feet. So it's not an error between, it's not checking for error between the two, it's the setting against field elevation.
Yeah, no, I concur.
And if there was a discrepancy between the left and right barometric altimeters identified during flight, let's say on the order of 100 feet, Mrs. Lewis, how would you verbalize that, or how would you triage that with the other pilot?
If there was a difference of around 100 feet, 100 feet, that's to maintain within 100 feet of altitude is the standard for us flying. So if it was right at about 100 feet, that would not give me much cause for alarm because it would still be within the standard of maintaining altitude within plus or minus 100 feet.
Mr. Bradham, when you were saying the additional 40-foot change on the transponder altitude, do you have documentation of that you could provide?
So the encoder standards, it's mil-spec 81852, which was the mil-spec for the altimeter. When in the encoder section, it says the standard is at the 50-foot mark plus or minus 40 feet from that. And so it's in mil-A 81852, it's paragraph 356, and under encoder it said the switching point shall be at altitudes 50 feet plus or minus 40 feet removed from the nominal indicated altitude.
Thank you very much.
Thank
And
you.
Michael Portman has another question.
Sorry to circle back. Just one last question for Mr. Gant. In Part 135, Appendix E, you had mentioned that there were standards for accuracy, in this case for altitude, that can vary between plus or minus 100 feet to plus or minus 700 feet. Can you clarify that those standards are plus or minus 100 feet that is recorded on the FDR as compared to what?
I would have to defer that question to get back with you folks.
Okay, thank you.
All right. Mr. Gant, the FAA has several restricted category UH-60L helicopters that are approved for civil use, including the Lima model. What are the static system and barometric altimeter design requirements for these restricted category helicopters?
So the FAA regulations for bringing in surplus military aircraft that have been designed and manufactured for use by the U.S. military, given a satisfactory operating history, which usually is at least 10 years, if they are surplus and they are determined to be airworthy by the FAA, they can come into the system utilizing, I'll say, the military records as well as military flight manuals. There will be no additional showing to the FAA to bring those aircraft and put them on the registry under restricted category. And under restricted category, that severely limits operations, mainly to agricultural, external load operations, and forest and wildlife management, which usually translates into firefighting operations.
Mrs. Lewis, can you just clarify for us, when flying low level, what would be the primary instrument you would reference for altitude?
The radar altimeter, in my experience.
And would that change when flying on a helicopter route with a ceiling?
If it's a published MSL route, I would still be referencing radar altitude, but I would also be taking barometric altitude into more consideration than what I normally would be if I was flying at a low altitude, if that makes sense.
Okay. And is that, so if I understand you correctly, you'd be referencing low altitude on a MSL route with a ceiling. You'd be referencing both the rad out and the barometric altimeter.
Yes.
And is that trained or is that a personal technique?
There's no standard for which instrument I would be looking at, but if I'm on an MSL route, I would have to be at some point referencing the barometric altitude to maintain the route altitude.
Okay. Thank you. Yeah, my question, I think, really was, is that a procedure that's trained in the Army to cross-reference those two instruments, one on a route of that nature, or is that more of a personal technique for you?
I would say that's more of a personal experience-based technique for me, but also coming back to if I'm on a published MSL route, the only way for me to maintain the prescribed altitude for that route would be to utilize my barometric altimeter as well.
Understood. Thank you.
Chairman Hamady, that will complete the technical panel's questions.
Thank you very much. We're going to take a 15-minute break. We'll be back and start promptly at 11:35. All right, I think there were some lines at the restroom, so we'll give it a few more minutes. Don't worry. All right, welcome back. We're ready to proceed with witness questions from the parties to the hearing. I'll speak slowly as people take their seats. Okay, each party will have 5 minutes to question the witnesses. We'll have 2 rounds And parties, please remember, you must limit your questions to the topics listed in the agenda. Please also refrain from asking questions that call for speculation or analysis. Finally, remember that only your designated spokesperson may question the witnesses. We'll start with the airline. I'm going to start with alphabetical. We'll change it up every single time. So we'll start with the Airline Pilots Association.
Thank you, Chairman. This first question is going to be for Chief Warrant Officer, Ms. Lewis. You spoke about referencing barometric altitude while flying an MSL or mean sea level altitude route. If the maximum altitude for the route is 200 feet MSL, would an error of up to 130 feet affect your operation and ability to fly that altitude accurately?
What's the 130-foot error that you're referencing?
So that's the specific potential altitude deviation we saw from 100 to 135 or 130 feet of the exemplar aircraft that was flying. So it's the potential barometric altitude discrepancy that we saw between the exemplar helos.
No, it would not affect my ability to fly that route as long as the aircraft altimeter setting is within 70 feet of field elevation for both the pilot and co-pilot altimeters. It would not affect my ability to fly that route.
Okay. Second question is going to be for Mr. Gant. As previously discussed, the NTSB and the Collins, they calculate a conceptual static error between the two systems. The error was calculated as 135 to 193 feet, depending on the assumed speed deviation. How does this affect safety of flight for helicopter routes with a maximum ceiling of 200 feet?
I'm not sure I fully understand the question.
So there was a conceptual static error that was calculated based on the forward speed of the helicopters. It was between 135 feet and 193 feet. This is from the Airworthiness Factual Report on page 53. How do you think that error, that altitude error of 135 to 193 feet, can affect the safety of flight for helicopter routes that have a maximum ceiling of 200 feet MSL?
Yeah, I'm going to defer an opinion on that. My area is really around the airworthiness of the aircraft and not the operational aspects, flying routes, low-level routes.
Would anyone else on the panel like to respond for us on that one?
I believe you're referring to, Collins did an analysis to determine when the airspeed capsule light would come on in terms of a difference between the two sides, but that's not what the airspeed capsule light, I'm not aware the airspeed capsule light was actually illuminated. I think that was just an attempt by Collins. I'd be speculating to the intent, but I think that's what the analysis was trying to say, and I'm not sure. I just recall those numbers.
Yeah. Yeah, I concur. Collins was trying to identify when an alert may be provided to the crew, what level of error. It did not mean that error was existing. And that alert is for something else. It's for flight path stabilization fault. It doesn't mean that error occurs. It's just they were trying to evaluate what could, at what limit would alert crew, and was that trying to scope the magnitude of the error that was present.
Thank you, sir. The next question, that is for you also, Mr. Cooper. Considering the increased airspace congestion across our continental United States, should older aircraft like the UH-60 Lima model, which lack a bit of modern instrumentation and rely on legacy systems, be more aggressively phased out, given that there's an increased potential risk in operations with commercial traffic?
I'm sorry, I think that's speculation, and my role is in engineering, design, and test, so I don't think I can comment on that area.
Okay. Last question for you, Mr. Cooper. Given that operational data from the UH-60 aircraft shows the deviations, once again, I'm referencing the 80 to 130 feet in the exemplary aircraft, between the field elevation and indicated barometric altitude, does Sikorsky view this as an acceptable margin within their flight envelope?
The data that was taken during that evaluation, understand how the test was executed, but as the Army has mentioned, that there were a series of factors, including the fact that one of the aircraft had an altimeter tested post that evaluation that was outside of the maintenance limits, and its vibrator function was not functioning, which in the mil spec for the indicator creates a larger instrument error allowance. I really cannot comment on that data because I do not believe it represents the aircraft's expected performance.
Thank you, sir. No more questions at this time.
Thank you. FAA.
Thank you, Madam Chairwoman. Mr. Gant, I just want to clarify one thing with you. Does the FAA evaluate or certify military helicopters to operate in the National Airspace System?
Yeah, well, there's two methodologies to get a military surplus aircraft into the system under 2125. I mentioned earlier, like a UH-1L designed and built for use by the U.S. military with satisfactory operating experience. If surplused out and can be determined to be airworthy, it can be accepted without further showing. There are other military helicopters that were derived from a commercial aircraft before it was militarized and went into military service. And in that case, if that aircraft was surplused, you could bring it back into the FAA system, if you will, either under restricted category, or you could return it to its original civilian configuration and get it, I'll say, recertified to the appropriate part that it was certified to originally to get a standard C of A, airworthiness certificate for that aircraft. So there's two paths. Both can lead to just restricted category operations, but either way, you're going to be operating in the NAS with with a restricted category airworthiness. Though you're very limited on what you're allowed to do.
Mr. Brandom, how often are the static altimeter calibration tests performed on Army aircraft?
Yeah, so the maintenance, the maintenance that's required is the pedostatic test procedure, and that's done every 12 months, which is, I believe the civil requirement is every 24 months.
Okay. And I'd like to follow up. Would an air traffic controller know that there was a discrepancy error in the altimetry system?
So I'm not being a controller. I'm not sure what information they have access to. I would say that certainly controllers, well, I'd be speculating other than to say that controllers must certainly be aware that there are error tolerances for barometric altimeters.
Based on what the transponder is sending out, would they see a difference from where the helicopter actually is?
Well, the encoding transponder, right, is sending pressure altitude, and it's sending it in 100-foot increments. And again, it has the encoder could be, if the actual altitude is 110 feet, the encoder could send 200 feet. Right. And so if the aircraft error is inside that band, then no, there wouldn't be any difference in what's being transmitted.
Okay, thank you. I yield back my time.
Thank you very much. We'll go with NADCA, air traffic controllers.
Thank you, Chair. We have no questions for the witnesses at this time. Thank you.
Thank you. PSA Airlines.
Thank you. A couple operational questions here real quick. Ms. Lewis, before I want to go back to some of the questions Mr. Banning asked was, you say that flying at low altitudes, you use the radar altimeter below 200 feet. But when flying on the published route, you'll use the MSL. You use a barometric altimeter.
That's correct.
Is there any published standard in the manuals for which altimeter you should be using? Or is it just up to the pilots?
There's not, but to go back to what I previously stated, if I'm flying a published MSL route, I would have to be referencing my barometric altimeter to stay on that route.
Sure. So is it left up to the pilots to decide which instrument is primary?
If I'm flying a published MSL route, I would have to be referencing my barometric altimeter in order to maintain the published route altitude. That's not to say that I wouldn't also be cross-checking my radar altimeter I'd be referencing multiple instruments as I was flying the route. I would be looking at both, but in order to stay on a route with a published MSL altitude, I would have to be in some part of my cross-check relying on my barometric altimeter.
Okay. So, yeah, I understand. And that's basically, is there any briefing that goes in before the flight if you're doing the low altitude flying with your pilot or the pilots up there to discuss which instrument they'll be using or cross-referencing or which one's primary?
In my experience, the crew would discuss the altitude of different routes of flight prior to flight, but there would not be a specific discussion as to what instrument we would be looking at in the cockpit along the route of flight.
In your experience, which instrument is more accurate?
I can't speak to the accuracy. That's a difficult question to answer as far as my experience, which instrument is more accurate. Both the radar altimeter and the barometric altimeter have tolerances, as Mr. Bradham has discussed, and as long as the aircraft is within those tolerances, I don't have any further reason to question, as a pilot, their accuracy.
Step back to my mic here a little bit. This is for you again, Ms. Lewis. You stated that at 100-foot discrepancy between the altimeters being used by each pilot would be within specs. Would your level of concern be raised where you are operating with a 200-foot ceiling?
I didn't say within specification. I said it would be within standard, as Army pilots are expected to hold their altitude plus or minus 100 feet. Mm-hmm. And as far as along the route of flight, no, that would not raise my level of concern if I was on a 200-foot MSL flight. That's just in my experience.
Yeah. Okay. I yield back the rest of my time. I have no more questions.
Thank you. Sikorsky,
Sikorsky has no questions at this time.
U.S. Army.
Thank you, Madam Chair. Just want to follow up on two questions. In reference to the earlier line of questioning about distance or height estimation while flying, I'd just like to ask both Ms. Lewis and Steve Bradham, based in that same vein, based on your confidence, what would you have a higher confidence level at low altitudes at nighttime using night vision goggles for height estimation or being unaided?
Night vision goggles, sir.
Yeah, sir, it's been a long time since I wore night vision goggles, but I'd say night vision goggles.
And then just a follow-up question for Steve Bradham. If we talked a lot about the inherent errors that are within acceptable range of the static system and the altimeters. Those can compile and still be within standard. Could you describe what the kind of max extent of that acceptable deviation could be, and that could be presented in the cockpit?
Yes, sir. So as I said, the way we do, the way we qualify these systems is we look at each error individually. Instrument errors inside the altimeter, the static position error of the aircraft, based on the flight condition, we have standards for those individually. When we talk about a stack, they can combine, but I'm not aware of a definitive standard for the combination because you have to deal with different flight conditions and whatnot. But there's a couple of different ways to look at that. One way is just to say the maximum instrument error you could see and fly the aircraft would be 70 feet on an altimeter. And then you would add position error to that, which by the spec would be 25 feet. So that's 95 feet of error. That doesn't include a mistake in the Colesman window or not having the right barometric pressure in the altimeter setting. So that's a kind of a rough approximation of a maximum error that you might see, 95, roughly 100 feet. I think if you did that same math on the civil side, you'd see their altimeter check was 75 feet, and 129, or sorry, fire part 29 gives you 30 feet of position error, so that'd be 105 feet.
Okay, thanks, Steve. Just to follow up with the FAA, and again, you probably can't answer this, but I'll put it on the record and we can come back to it in a later session. How does the FAA account for the known deviations within instrumentation errors that are acceptable?
Pretty much as already described. Again, the Airman's Information Manual, I think even in the IFR Flying Handbook, talks about setting your barometric altimeter on the ground and verifying with you're within 75 feet of field elevation, and then the periodic checks every 24 months to do the ground tests of the altimeter system.
The Army has no more questions. Thanks.
Thank you very much. We're going to turn to the Board of Inquiry, and I'm going to go ahead and start. Ms. Lewis, I have a few questions. First of all, I just want to clarify. If you're on a published MSL route with maximum altitude of 200 feet, I'm going to be even more clear. You're on the Potomac River, maximum altitude 200 feet. Would you be referencing your barometric altimeter or your radio altimeter?
I would reference both, ma'am.
You would reference both. And is that by practice or by policy?
That would be by practice, ma'am.
Okay. Would it surprise you if we interviewed standardization pilots and other pilots at the 12th Battalion who said they relied on the barometric altimeter?
Would that surprise me? I would be surprised. I would think most pilots would be cross-checking both in those conditions, ma'am.
Mm-hmm. Okay. But is there a policy?
No, ma'am. There's no policy of
It's by
which
training and by
instrument
practice
specifically to look at.
Okay, great. So the formation flight of the 12th Battalion, the tests we did at Davison Airfield, true altitude is 45 feet. So Ms. Lewis, the barometric altimeter on the ground, no rotors turning for one of the helicopters showed 0 feet. Would that concern you at all, and why not?
No, it would not. The field elevation there being 45 feet, that would be within the 70-foot
Within the plus or minus 70 feet?
Yes.
Okay, and so the expectation once you take off, rotors are turning, you lift, you do a hover check, you take off. Are you thinking about that plus or minus 70 feet, or you've checked it at Davison Airfield and you say, okay, it's within tolerance, I can go? You're not doing math the entire time, correct?
I would not be doing math the entire time in my experience.
Great. So then you have, so for our test, rotors turning 100%, no collective input, again, 45 feet. All of a sudden, the barometric altimeter drops to negative 25 feet. Is that a concern, and why not?
Ma'am, might I speak to that?
Yeah, sure.
Ma'am, when you pick it up to hover, when you have rotors turning, what you're seeing is the rotor wake influence on the pitot tubes, and it's a standard effect, and I think pilots are aware of that effect, but they're not really looking at barometric altitude because we know below 40 knots.
You're looking at radio altitude.
Well, yes, ma'am, particularly at low speed. When you pick up to a hover, you're not picking up to a hover based on barometric altitude.
Plus, it's within tolerance. Okay. So now you're doing a hover check, drops to negative 50 feet. Any concerns there?
No.
Okay. Why not?
Because I would be looking at radar altitude at a hover, ma'am.
Okay, great. And now you are flying over terrain. Your barometric altimeter is negative 50 feet. Radio altimeter is 14 feet. You're at 60 feet. Do you have any concerns about the discrepancy? Off by 110 feet. You're probably not doing math, though, right? You're probably looking at your radio altimeter right then.
Yes, that's correct. I would be looking at my radar altimeter at that point in time.
Okay, now you're over the Potomac River in this area of the crash. Let's say your barometric altimeter says 1,070 feet. Your radio altimeter says 1,200 feet. There's a difference of 130 feet. Do you question it? You're looking at both? Which one do you go with? You're on an MSL route, max 200 feet, altitude, or not, let's just say 2,000 feet. 1,070 feet, 1,200 feet.
I would be referencing my barometric altimeter at that altitude.
Okay, and plus you said 100-foot difference, you said is not cause for concern.
Correct.
So you're looking at your barometric altimeter, which is 1,070 feet. What happens if you're on the Route 4 near the area of this midair collision, max 200 feet, and you're looking at your barometric altimeter, which you should be which you said you would be looking at, and you know there is a 75 feet between the glide slope and the east bank of the Potomac River. Would that cause for concern if you had a 100-foot discrepancy between the two? And which one would you go with then?
If I knew those facts ahead of time going into that situation, I would be referencing the barometric altitude very heavily, but I would also still be doing that quick cross-check of radio altitude to determine what altitude I was at that point.
And that's assuming you knew it?
Assuming I knew that ahead of time, yes.
Right, okay. Do you think you should know those things?
Can you clarify exactly which things?
Sorry. Do you think, sorry about that. You think you should know where those, if you're operating at such low altitude, do you think you should know when there's only 75 feet and your max altitude is 200 feet?
Yes, I would very much like to know that.
Okay, thank you very much. And thank you for your responses. For the Army, have you looked anywhere else in the national airspace to see if this sort of, oh, I'm over time. I'm so sorry. I will add 2 minutes to their time. We'll go on to Member Graham, add 2 minutes to theirs.
Not a problem. Okay. Ms. Lewis, you pretty much have said that when an Army pilot begins a hover of their aircraft, that they are looking at the radar altimeter. Is that correct?
That's correct.
Is there an altitude after the hover as you depart the field or where you take off from that you transition to barometric altimeter?
In my experience, it's not a set altitude, but as I'm climbing out of the airfield and once I'm no longer at a hover, generally I'll start referencing my barometric altimeter more heavily than I would have been before.
Okay. Is there a set altitude where a helicopter pilot in the Army should be transitioning to a radar altimeter?
There's no exact set altitude, but anytime I'm conducting, say, terrain flight 200 feet or below, I would generally be referencing my radar altimeter.
200 feet or below would,
yes.
Yeah, okay.
And that's just in my experience.
Your experience, okay. How do Army pilots ensure obstacle and terrain clearance while flying the Washington routes or at a low altitude?
In my experience, I've never personally flown the Washington helicopter routes.
Okay. Mr. Bradham, have you flown the routes?
I have not, sir, but I know on subsequent panels you have an Army witness who's very experienced. He's a standardization instructor pilot for that
I'll
unit.
ask him those. But in your experience, Ms. Lewis, how do you keep obstacle clearance or terrain clearance while flying at low altitude? What altimeters are you using?
My radar altimeter.
Your radar altimeter. Okay. I assume you both have seen the Washington routes and their barometric routes. Have you seen other routes like this that are similar to Washington? Either one of you.
Sir, I'm trying to think. In my experience, I don't think I have seen a I certainly haven't seen one that has such narrow vertical separation with an approach path the way that Route 4 and Runway 33 do. There are other helo routes through Class B airspace, but I'm not the.
Okay.
I'd be speculating, sir, if I went further than that.
I flew low altitude at fixed wing in the military, and I thought it was very unusual to see routes 200 feet or less, 300 feet or less that are MSL routes. And I'm looking to see, do you know of any other routes like that that are defined that way, that low to the ground?
Yeah, I do not, sir.
I thought these were very unusual myself. Let me switch here just a bit. Let's, I think we were talking about the Mode C altimeter, what the transponder that sets the altitude, sends the message out on the altitude of the aircraft. And that is sent out, is my understanding, on the Lima model from the right side. Is that correct?
That's correct, sir.
Is that the default, or is that the only one that sends out the
So that's the only one. So the right side altimeter is an encoding altimeter, the left side is not.
The left side is not. So this analog, there's only one.
Yes,
There's
sir.
Does the mic model have the ability to change which altimeter sends out?
Yes, it does, because it has a different design. Its integrated system has a redundancy capability where if one fails, there is an alternate data path from the other sensor.
Well, let me stay with you on that, Mr. Cooper. So the Lima model, if there's a large altitude split between barometric altimeters, there's going to be no indication to the crew that's alerting them that there's a large split in the altimeter. Is that correct? Other than the crew looking and noticing it and talking about it. Would that be correct?
Correct.
What about the mic model? Is there something in the air data computer that if there's enough altitude split between the two, that they're going to get an indication that something's not right?
The capability exists. It's in the multifunction display system and software. It identifies whether the selected altitude between the pilots is over a limit.
Okay.
Because they both, the design has the capability to select the same sensor. So it's meant to not only catch sensors, but display issues. So it compares displayed altitude.
Most aircraft that I'm aware of, fixed wing and otherwise, that have air data computers have a system like that and have a maximum split where there's going to be an error that will notify the crew that something's off. Would that be a correct statement?
All I can talk to is there are other modern Sikorsky helicopters that also have that miscompare capability. In the analog era of the Black Hawk and even the original 76 when it was analog, that capability couldn't be implemented because the hardware means didn't support it.
Okay. This aircraft, I believe, was delivered in 2000. Am I correct on that?
2001.
2001. Are they still making the Lima model?
It is not in production now.
When was the last year Lima was made? Lima was.
I don't have that date.
Okay. Does the Army have a plan for phasing out Lima models?
Yes, sir. We have a divestiture plan for the Limas that's currently ongoing, and so the plan is to replace the Limas with the mics because they are much more capable, as you've alluded to.
What's the average life of a Lima model?
Since they came into service 1989 or so, right?
Yeah, the first Lima was delivered in October of 1989.
And do you know what the average life that the Army is getting out of the Lima?
I can provide that data. The specific data is post this investment. I don't have it in front of me now.
Okay, that'd be great. Thank you very much. I see my time's up.
Member Inman.
Thank you, Chair. And Mr. Rosengren, I'm going to start with you. And I will start with this. I thought I was going to be much more frustrated by the second panel, but I'm already that way. So I'm going to ask a very simple question. You just said you don't know the divestiture schedule for these models, correct?
No, sir. We know the divestiture schedule. What we don't have, I don't have the data in front of me, is the average life of,
Okay.
of the Limas. We can get that down to you by tail number.
But earlier you said your only plan right now, based on the work that these experts have done and the research, your plan is that you hope in 2 weeks is to update something in a manual for them to tell them about this discrepancy? That's the only update you plan?
No, sir. We've asked our airworthiness organization to give us a recommendation. Once we get that recommendation, if it is determined to be a risk, we hold a system safety working group, which has user representations, safety representation, PM representation, and that safety body, independent safety body, will make a recommendation to the PM and the program executive office, which will be
Okay, hang on a
active.
second. What are you going to do in 2 weeks?
In 2 weeks, we'll get back the analysis from our airworthiness organization, the System Requirements Directorate.
So you don't even know if you're going to make any changes based upon the research we've already done?
So when we get the data back, then we will take that recommendation from our independent airworthiness organization, and then we will take appropriate steps.
Who is your independent airworthiness organization?
The System Requirements Directorate is the independent airworthiness organization that Mr. Bradham works for under the Aviation and Missile Command, which is a separate command, a separate four-star command that ultimately reports up to different change.
So I guess the bigger question is, are you telling me right now then, from what you've seen already, these Lima models are safe to operate in the national airspace?
So based on the specifications of operating the national airspace, we do meet the specifications of operating the national airspace. So with
Okay,
that,
then I'll stop you then. The next question is, are the specifications wrong?
so that's something I cannot speak to because I'm not necessarily an expert of flying in the national airspace. But when we receive the requirements, we make sure we comply with the requirements.
Okay, who can speak to that?
So the FAA provides the requirements for flying in the national airspace.
And then the military describes, or basically sets the parameters for how to design the airplane or the helicopter?
So when for a military aircraft to fly in the national airspace, we have to go through the same qualifications as any commercial aircraft. So we don't own those requirements for flying in the national airspace. We only comply with them.
FAA, would you like to comment on that?
Well, again, the civil aircraft flying in the NAS, if they're under a standard certificate of airworthiness, have met all the design standards at the time that they were certified.
Okay. So I just want to clarify something else because I think it's important because there's a lot of important people that worked on these airplanes. The altimeter differences that they've been discussing recently are not the effect of a maintenance issue, but it's a design issue.
Sir, I think what the discrepancies that have been seen can be explained by a stack of the different errors between instrument and static position error, and, for example, the temperature effects on the in the 15th of May for that particular set of flights. So I think you can explain that deviation as being within the tolerance band for those different errors.
How much tolerance should we have for aviation safety whenever civilian lives are at risk?
Yes, sir. Safety is critically
No,
important.
I ask you, how much tolerance for safety should there be when civilian lives are at risk?
Sir, in terms of airspace separation, for how much separation should there be between aircraft that are using barometric altimeters?
No, you just told me, I believe, all of this equipment in this manufacturing process is within the tolerances for safety. How much is that tolerance? I think it should be zero.
Sir, I think your line of questioning, I had those similar thoughts when I saw some of the data that your team poured up with. And then when Mr. Bradham walked me through, here's the physical limitations. There's nothing anyone can do when we have these machines that provide this data. And so we have to understand there are physical limitations to that, which is offhand plus or minus 100 feet. So from my perspective, when I was flying out here, going to fly in on the exact flight that had the accident. And so my condolences to the families. I can't imagine what you're going through. My thoughts and prayers are with you. But knowing that there's plus or minus 100 feet, any qualified Army pilot or any civil pilot will go, the fact that we have less than 500-foot separation is a concern for me personally.
Okay, so I'll ask you this question. There was a quote, someone said, modernization decisions made this decade will affect the next generation of Army aviators. Do you remember that one?
Yes, sir, I wrote that article.
And that article described how we need to update and outfit with additional technologies?
Yes, sir, Black Hawks are going to fly for another 50 years, and so I think it's very, very pertinent and very vital to upgrade the Black Hawk fleet today so that we can have 60 mics and even more capable aircraft in the future.
So should the Limas be flying today?
If I was king for a day, I would take all the Limas out of the fleet today and replace them with mics and make them better so that our soldiers have the most effective
Well,
lethal
you're not the
fighting
king.
aircraft. No, sir, I'm not.
I'll pass to the next round, Chair.
Thank you, Member Inman. Great questions. Are you a party? Is the Army a party to this investigation?
Yes, ma'am.
So the reason why we have parties to investigations, the entire reason, is so that you can get data and get access to what we're finding in real time so you can make safety change immediately and not wait till the end of our investigation to do that safety change. When did the formation flight occur?
May 15th.
May 15th. So I'm a little bit confused. You have this formation flight, you know the discrepancies. What is the Army doing with the Limas, either at the battalion or the fleet, to address this? Do you plan? Did you test the other helicopters or the other Limas at the battalion?
So when
Yes or no? Did you test the other Limas at the at the 12th Battalion to look at whether there were any discrepancies outside of what you would anticipate?
I'd have to defer to the 12th Aviation Brigade for their maintenance schedule.
Okay, how about Army-wide?
So when we discovered the discrepancies on May 15th with some of the altitude, we queried our Sikorsky friends and got the data. We verified that the data wasn't...
Wait. When was that data obtained by you?
The Sikorsky data?
Mm.
So it was obtained in 1983. We have a model-based...
No, that you just asked for.
That was the 50-foot ESSS error, or external source support error.
Ma'am, I can speak
Thank
to that.
you.
So it came out of the factual report that came from one of the exhibits here that Sikorsky had provided input to, and we then went through the history of that, and we looked at a number of potential contributors. We wanted to make sure that that error existed in 1983. We confirmed that. We wanted to make sure that that error still exists, because there have been some changes to the aircraft over time. Went back through our airspeed calibration records, through some other, investigated some other questions to make sure that in fact that error exists. We have, right before this hearing, have gone through all our models and verified that we believe that that error exists.
Which error specifically?
And I'm speaking to the position error for the external storage support system with one tank on each side. So that position error of about 40 feet at 80 knots and about 50 feet at 100 knots.
Okay, so you mentioned, so you do not actually plan to test the other Limas to see if there are any unanticipated discrepancies in barometric altimeters?
So based on the flight test records we have today, we don't see a need to test the Limas because the configurations are standard across the fleet.
Do you have, is there other airspace, anywhere in the national airspace where this may be similar? Have you checked?
Ma'am, we did do a search to look to see if there had been any safety incidents on the Black Hawk related to the pitot-static system. We did not find any.
Did you work with FAA to look at the glide slope for any landing aircraft to make sure at any runway at other airports across the nation where you might have this same issue?
No, ma'am.
Okay. So policy-wise, you said you're putting something in a flight manual?
So there's several courses of action that could happen based on the recommendation from our airworthiness organization. We could update the flight manual to include the air table, we could take the air altitude correction table. We could put out an
Okay, I'm running
airworthiness
out of
release.
time. I want you to walk us through when that started, what each of the steps are to get to the end of that, to where you have a policy and a manual, or whatever the recommendations are in the airworthiness group. What are each of the steps, and when will that occur? How many steps? I mean, not just how many. Walk us through that process.
Sure.
Ma'am, so the moment it was identified, the first step was making sure that in fact that error did exist, and that was going through all of our models. That's complete. We've looked at a number of things to try to make sure that that error hasn't been changed over time, and we've verified that. So that analysis is complete. Our aeromechanics group inside our airworthiness organization has completed that analysis. They should be providing the recommendation back over to the program office to provide our recommendation for what should be added to an operator's manual, or how the pilot should be made aware of that that altimeter correction for the ESSS configuration, and then that'll go into the PM office for decision.
Then there will be a system safety working group that'll determine if there needs to be a aviation safety action message for immediate notification, or if it will go into a 2028 process to update the technical publications, or if it'll go in an airworthiness release. So that'd be the third and fourth final step.
How long will that take?
Once we get the memo back, so the recommendation, we can convene within a week, and then following the SysWig, we can determine, if it's an aviation safety action message, and that's coordinated through our aviation and missile command, and that can happen within days. And if it's updated into a manual, we'd first put it in the AWR. Again, that's within days to weeks. If it goes into the manual, the 2028 process, there's a little bit longer, but we would put it in the AWR first so it's notified, and then the manual change would come out following that.
Okay. I need, how long do you believe this entire process will be?
So from today, being, let's say, July, the end of July, so by the end of August, the SysWig should have met, and so early September, we should have the direction that'll come out of the System Safety Working Group, and then that'll determine the ASAM, the AWR, and/or the manual path.
Okay.
So September 15th ballpark.
And that's just the recommendation?
No, that's for the final action.
That is for the final action?
With the caveat that if it is determined to update the manual, that would take a longer process. The AWR would go out in the interim until the operator's manual is updated.
Thank you.
I got a couple questions on the flight data recorder. As part of our investigation up this point, radio keying was supposed to be recorded per the recorder documentation, but that data was not present. Do we know why?
So we sent a team down to a unit in Alabama and verified that data is not being downloaded. We're currently investigating that, and we don't know why that data is currently not being downloaded or not being input into the system. So it's an open issue that we're investigating.
Okay, and I assume our investigative team's tied in with that as when you guys know something?
Yes, sir. We would let them know
Okay.
when we find something out.
Yeah, for you, Mr. Rosengren, you indicated the accuracy of the flight data recorders are checked whenever there's a software upgrade. How often are there software upgrades?
So for the for this particular system, there was a substantial software update in 2011, and then there was minor updates in 2013, 2015, and 2017, and we're currently undergoing an effort to make another software upgrade right now.
Okay. And you did mention something about there was some thought behind doing a FOQA program with the flight data recorders, is that correct?
Yes, sir. We had an aviation data exploitation capability program back in the mid 2010s. That didn't come to fruition.
Okay. Do we know why it didn't?
I can't speak to the decision of the acquisition professionals, but I believe it just didn't make it past the certain checkpoints during acquisition programs.
Okay, thank you for that. That's all the questions I have for this panel. I want to thank the witnesses.
Member Inman.
Thank you, Chair. Mr. Rosenberg, I'm going to go back one more time. You're saying middle of September, you're going to inform or hope to inform Army aviators of what?
If there's a change for the altitude with external storage support system on the aircraft, if there's a recommended delta altitude discrepancy.
Yeah, see, I think, Chair, just let me clarify one thing too, and I want to point this out. The parties that have been involved with us from the Army have been very helpful and I think worked with us very well. I think that was discussed earlier, so we're appreciative of this. This is the first time we're actually interacting with you all as witnesses, which is, I think, is probably some of our frustration of what we're hearing in this testimony. And the reason I bring that up is, in a personal sense, I used to live at 400 Army Navy Drive when this crash occurred. I looked out over the Pentagon, DCA. Chair and I stood on runway 33 the night that this accident happened. I moved to McLean specifically so I wouldn't have to face that and my wife wouldn't have to see me wake up in the middle of the night. Whenever I moved to McLean, though, I found out after being there the last 2 weeks, I'm on one of your flight paths over 495. Over the last weekend, 5 of those Limas flew behind my house. And you're telling me it's going to be 2 months before you tell them that there's a discrepancy in their altitude? Could you hurry it up?
Yes, sir. We will do. That's a worst case scenario. We'll do everything to exceed that time frame.
How about telling them now?
We are in public testimony, and so we have put it out there in public testimony.
I hope every Army aviator is not having to watch the ntsb.gov live stream to figure out that there's a discrepancy in their altitudes of the planes that are flying around us. Sorry for my frustration. For Sikorsky, how many of these Lima models are still in operation around the world?
Sorry, I don't have that number. I'd have to, I cannot answer the Army numbers, and we'd have to go back to determine our international operators.
Could you please?
Okay.
How many were manufactured with this variant, I guess, is a good question. How many are still operating with a certificate?
Yeah, we'll find out. We can get the answer to both.
Okay. Has Sikorsky received any reports of conflicting altitude readings elsewhere outside of the military?
No, the answer is no. I requested information from our database and went through it, and I did not see any reports as such.
How much does a Lima model, how much did you sell a Lima model for?
I'm sorry, I'm engineering. I don't know the cost data.
Okay, can someone from the Army say how much you paid for a Lima model?
I don't have that data either, but we'd be happy to provide that for you.
That and how much the Mike model cost?
Yes, sir.
We also noted that, I believe it's in the chairman's, or the group chairman's report, and I'm going to just cite it a little bit, if I can pull it up here. That this altimeter was actually returned for service and reconfigured. Are you aware of that? The right altimeter?
I was not aware of that, sir.
Okay, it's in the group chairman's report for helicopters. Have you read the group chairman's report for helicopters?
Yes, sir. I've read all the exhibits for this hearing.
Well, I'd refer you to page 39 and 40. So if you don't know that that was done, I think it would be helpful to read it.
Oh.
Both the PITX, the altimeter had been overhauled and recertified in 2018. Have you went back and looked at other recertifications and overhauls of altimeters to see if they're still within specs?
We have not, sir. And the device is a non-condition item, so it's only overhauled once it's it doesn't get pulled and overhauled on a regular interval. It only comes out when it no longer passes its checks.
So one final question before my time runs out. So the Army determines the mil spec for not only where the pitot tube is, now I apologize if I'm mispronouncing it, the pitot tube where it goes, but it specifies specifically the altimeter that must be used with it. Is that correct?
the original requirement specified the altimeter to use and actually provide it as government furnished property, but it did not specify where the probes would go.
So was that Sikorsky's decision of where the probe would go?
That was before my time, but I would believe so, yes.
And you earlier said that that was technology, I guess, in the 70s at the time that it was decided, right? Before you had flow test and other type of testing?
That is correct.
Have you not reevaluated that to test to determine if a design change should occur now that you have new methods?
No. Again, there's been no further requirements for any different.
No, I'm not asking about a requirement. Has Sikorsky, now that it has additional ways to test, maybe went back and looked at its aircraft and said, we know better things, we should suggest a change in where these pitot tubes go?
No.
Any reason why?
As I stated before, when you consider there's limited real estate on that aircraft where these could be put, and other operational considerations. So again, austere landing conditions, worrying about damage to their probes, debris impacting the pitot or static ports. The other devices on the aircraft which would limit separate static ports like what was shown in the presentation. So again, limited areas and no identified need for different performance.
We'll keep going. All right. While I am asking this question, can Mr. Fuchs, can you pull up, I think we sent it to you, 7 Helo H Appendix A, Table A1. Before I ask that question, though, for the transponder, I just want to go back to the, well, actually, before I go to the transponder, you said, Mr. Rosengren, you had said possibly a safety alert in September or some sort of alert, correct?
Yes, ma'am. We could send out an aviation safety action message that would go out to the fleet.
Okay. And then when is the first chance for it to go in the manual?
So the manual goes through a 2028 process. So that would begin in lieu of going into the manual, we would put it immediately in the airworthiness release that would go fleet-wide.
Okay, but manual, that update begins in 2028.
So, I'm sorry, 2028 is the form that is submitted to make an operator's manual change, not the calendar year 2028.
Okay. But 2028?
No, ma'am.
Okay, please be very clear.
Yes, ma'am.
Alert, manual.
So manual, there's a process that uses a form 2028. And that form 2028, if it's determined it needs to go into the operator's manual, we would submit that by the September 15th timeline. When it goes into the process of updating an operator's manual, that I can't speak to the specifics. I can get you the specific timelines of when an operator's manual would be updated.
Thank you very much.
I apologize for the confusion.
No, that's okay. Transponder, let's say you're at 260 or 270 feet. What would DCA tower see?
So, ma'am, at 260 feet, the tower should see 300.
Great.
But they get pressure altitude as opposed to what the pilot sees.
And 230 or 240?
It should be 200.
Okay.
But there's a plus or minus 40 around the midpoint.
Right.
Yes, ma'am.
Okay, thank you. Appendix A, Brian, if you can pull that up real quick. So we have a compilation of essentially error allowances. 2 in the static system, 1, 2, 3 barometric altimeter encoder. Well, actually 1, 2, 3, 4, 5, 6, 7 different standards for the barometric altimeter. We've got the ESSS. We've got a clean configuration of the Lima. Are any of these additive?
Yes, ma'am. Some are additive, and some are not. The way the table's laid out. So, for example, the encoder is not part of what the pilot sees, so that's not additive. But they're the instrument errors. The errors inside the instrument tend to be random, and they can combine. But so, for example, if you had a 30-foot scale error and a 25-foot barometric setting scale error, you would combine those through a method called the root sum of squares, and you would get roughly, that's a 39-foot expected error range for
And
those. So some of them are additive. Yes, ma'am.
Thank you. For what the pilot is seeing, are any of these additive?
Yes, ma'am. So the instrument errors, and those are the ones you're verifying on the ground when you do the pre-flight check or when you do the pedostatic check. Then you have to, when you take off in flight at a particular flight condition, you have a position error, a static position error, and those are additive. They can be different, so one can be positive and one can be negative, and they can cancel each other out, or they can add to each other, but they are additive.
Okay, and does it depend, could it be different by helicopter, or is that fleet-wide?
Yeah, ma'am. So the instrument error would be different by altimeter. So the
By
right side and the
altimeter.
left side altimeter could have different instrument errors. It's just a random, it's a mechanical error inside the device. But the position error, so for example, the position error at a particular airspeed for a particular flight condition is the same for all the helicopters.
Okay, thank you very much. I will ask Member Graham next. Member Inman.
Mr. Rosenberg, is your department or your agency, are you responsible for all updates in regard to even maintenance, or is it just flight standards?
So my organization is the Utility Helicopter Project Office, and so we're responsible for acquiring new Black Hawk helicopters, and then we coordinate with our life cycle management program, the AMCOM, Aviation Missile Command, on the sustainment of the aircraft. And so we do not have maintenance standards that we own. We're an acquisition organization, not an operational organization.
So you buy stuff, you don't use it?
So we buy stuff, and then we work with our sister commands to make sure that it's used in accordance with the acquirer's maintenance procedures.
Okay, so you're in charge of acquisitions, is that right?
Yeah, so we're part of the Assistant Secretary of the Army for the Acquisition, Logistics, and Technology. And so we are the acquisition arm of the Army.
So just help me understand this then. Why does the acquisitions department issue airworthiness directives?
So the acquisition, we do not. We get them from our independent airworthiness organization. So AMCOM.
You keep pointing to the gentleman to the
I'm sorry.
right.
So Mr. Bradham is my chief airworthiness engineer. So
But he reports to you, right?
He does not, no, sir. He's
No, sir. Just for clarification, sir, I'm the chief airworthiness engineer, and I work in Futures Command in the Combat Capabilities Development Command Aviation and Missile Center in a group called the Systems Readiness Directorate. So Army Airworthiness Authority is delegated from the commander of Aviation and Missile Command to the director of the Systems Readiness Directorate. So I report through Futures Command, not through the program.
My apologies. I thought earlier in the testimony you said my bosses and you pointed to the left.
Oh,
So often the acquisition, we will task them to give us independent recommendations. That's probably why the gesture might have been that way. So when I tasked Mr. Brown's organization to give me a recommendation, that was probably, if I recall, maybe.
Have you tasked his organization to give you any other recommendations regarding this accident?
Many, yes, sir.
What were they?
I'd have to go through the records. I'd be happy to provide you all the taskings we've done. I believe we've shared.
Are there a lot of tasks, a few tasks, 2 tasks?
There's many tasks. When Mr. Parker would make a recommendation, we would funnel it through our program executive officer, General Phillips, and then we'd make sure we get all the requests from this acts investigation, give it highest priority, and make sure that we get it tasked and recorded per saving the records for this investigation.
Okay. Will you be on another panel, Mr. Rosenberg?
No, sir, but I'll be here all week.
You think? Okay. I'm going to be done for.
Well, okay. I have a few just that I want to make sure I get back to. for Sikorsky, what's the prime item developments? What is a prime item development specification?
That is the document which with the government conveyed its requirements to us.
Okay, and when you're doing testing and you certify your, it goes through design and certification, correct? Your helicopters?
It's designed, and then we provide the reports. Ultimately, the
Okay.
Army has airworthiness ownership.
And so the documents you provided, does it include all these allowable allowances for errors?
The report that we've cited to the investigative team identifies the error curves for altitude, yes.
The report, and that was provided to the Army?
To the best of my knowledge, yes.
Okay, so my question is, was FAA aware of any of this? Or the testing that was done, was that a surprise to the FAA of what was done and what the outcome was?
I do not know.
Oh, I'm not asking
Oh,
you.
sorry.
I'm actually asking the FAA.
Which
You should not answer that question.
which testing are you referring to?
The tests that were done on May 15th on the formation flight.
And
I'm sorry, let me clear. The report I was talking about was from
Yeah,
1983.
I know.
Okay.
I'm not, this is a totally different question. I'm getting a few of my straggler questions here.
yeah, so I'm familiar with those reports that came out of the May 15th battalion flight tests. I didn't have access to any of the, I'll say, the original Sikorsky data to form any opinion on the results.
Okay, thank you. Member Graham. Member Inman.
Yeah, I'd just like to go back to Mrs. Lewis. I think all the board members were offered, and I believe we all took the opportunity to do a simulation in the Lima or the Mike model and to wear night vision goggles. And it was very apparent as we were doing that, the instructor pilots next to us were talking us through what they would see. So we've actually seen the entire route, which is pretty disturbing whenever you look at it that way. My question to you is they were talking to us and we're looking through night vision goggles. You have to look out of the night vision goggles, if I'm correct, to be able to check your altitude?
Yes, that would be correct.
And earlier you said that you'd be checking your radar altimeter and your baro altimeter if you're at an MSL of 200?
Yes.
Is it a complicated task to be looking at two separate altimeter readings while at the same time using night vision goggles that prohibit your view by 40 degrees? And an iPad, sorry, that has ForeFlight along with an ADS-B receiver that's remote?
Sir, in that situation at that low altitude, I would not be referencing an iPad. I would have that put away, but I mean, it does take some practice, some experience to get used to cross-checking the instruments while flying goggles at a low altitude.
How much practice and experience would you need?
I think it would vary by the individual.
So let me just clarify that again. And the chair brought up a good point regarding the iPad, which has the ForeFlight, which is where their charts are supposed to be, correct?
That's correct.
So let me go back to, you have a night vision goggles on with a 40-degree field. We now need to check the radar altimeter, the baro altimeter, but we don't need to be looking at the iPad?
As I had stated before, I haven't flown this particular route, but at that low of an altitude, in my experience, I would want to know the route that I was on, that close to the ground, and not have to be looking inside the aircraft in an iPad.
So with the instruction as a standardization pilot, would the instruction be to not have aviators look at their iPad, which has the charts on it?
In my experience, at that altitude, I would not want someone inside the aircraft looking at an iPad.
Well, can we hold until panel 3 on
Yeah,
that
that's
one?
fine.
And then if you'd like, we could recall the witness for that panel.
And I realize you may not have flown this route, I apologize. Have you had a chance to read all of the docket material that we've released, Mrs. Lewis?
I've reviewed all of the docket material for the air data systems and altimeters.
Did you find anything disturbing in what you read?
In my opinion, the amount of clearance between the helicopter route and potentially the altitude of an aircraft passing over top of it was concerning.
I hope so. Okay, thank you, Chair.
Thank you so much. Now, I'm going to go back to the technical panel to see if they have other questions. And then my understanding is, because I'm getting texts from the team, that there are some party questions. So I want to make sure we are within schedule, so I want to make sure everybody's questions are answered. So we'll go back to technical team, then we'll come back to the parties.
This question's for Mr. Rosengren. Previously with the flight data recorder, you had mentioned that when the data is downloaded, it's looked for reasonableness. Is there a standard for reasonableness with the FDR data?
So just for clarification, we don't download the FDR data. We download the HUMS data, which is in the data card, but they come from the same remote data concentrator, so we're confident that they're similar, minus a few recording rate differences in hertz. So we download the HUMS data. I'm not aware of any standards. I can get back to you if I find anything different. One thing does come to mind. So the 3 parts that I did mention, there are some vibration standards we look for to make sure that those 3 parts aren't exceeded. But outside of those three parts that we track, I don't know of any particular standards we use.
Okay, we'd appreciate it if you could get us that information, and particularly if the pressure altitude data is looked for, and if there's a standard for what's considered reasonable for that parameter. Jumping a bit, my next question is for Mrs. Lewis. This is a scenario-based one, based on what the chairwoman asked about flying over the Potomac River route. If you had a route ceiling of about 200 feet, and you were to look at your barometric altimeter and see about 160 feet, but then saw on your radar altimeter about 280 feet, how would you triage that situation in your experience?
In my experience, so if the barometric altimeter is reading 160 feet, you're saying, and the radar altimeter is reading significantly higher than that, I would still, my primary concern on the MSL route would be staying below the 200 feet. And I would definitely, take note of that and maybe write the aircraft up for some, maintenance action. But at that particular time, I would, as long as there was nothing wrong with the aircraft before we took off as far as the field elevation and the barometric altimeter, I would, continue to assume that I was below that 200-foot MSL.
Thank you. And then my last follow-up question is, I think Mr. Bradham would be best suited, but Mr. Rosengren can chime in as well. Based on the discussions today for the answers that we've received today in panel 1, there have been limitations identified with the accuracy of barometric altimeters just as a technology. They're mechanical instruments compared to newer air data computers and more modern technology. So knowing that based on our testing and just based on experience that these older technologies have these limitations that can create larger altitude offsets between indicated altitude to where the helicopter is actually at, what sort of considerations would the Army have for when flying in the national airspace system where pressure altitude accuracy is crucial?
So I think there's a question about the size of expected altimeter error versus aircraft separation when you're talking about a route like this in the national airspace, and I think that's not. I'm certainly not an expert to talk on the route design and the amount of allowable separation, but clearly, when you take into account you know, there's standards for pilots to maintain altitude. There's standards, you know, for the altimeter error. And as you know, thinking about this, I don't think that we envision a situation where, well, prior to this incident, myself personally, in my experience, I wouldn't have envisioned a situation where you'd be operating on barometric altimeter, you know, with less than a 500-foot separation. But I think if you're asking if we're kind of relooking how we operate in the national airspace, I don't, with the exception perhaps of the correction for the ESSS configuration, I don't believe there's any deviance from what's accepted on the civil side as well. I mean, the military requirements, the 70-foot check is more stringent than the 75-foot check. The mil-spec 25 feet of position error is more stringent than the civil 30 feet of position error. So with that one exception, I think we're still operating inside the requirements.
And would there be any considerations to selecting certain models that have newer technologies or more accurate instrumentation versus older models in flying certain missions based on, again, known limitations with route ceilings or proximity to civil aircraft in the national airspace?
Yeah, I think that's an operational question, and I don't know that I could speak to that.
Is there someone here that can, as a witness?
I think it'd probably be best to wait for more operational, experienced witnesses to give more expert testimony.
Thank you.
Yes, just one follow-up question. Mr. Rosengren or Mr. Bradham, given your knowledge of the various electronic devices on the UH-60L model, are there systems that are currently installed that record the helicopter's position and either radar or geometric altitude over time that could be used for operational data monitoring for safety assurance purposes?
So we do include the radar altitude in our parameter data and the flight data recorder and the HUMS data, so that can be used. We don't record the GPS data.
Okay, and does that, where do those data go?
So that data goes to the same places, the flight data recorder and the health and usage monitoring system. I'll call it a card, PCMCA card. So those are downloaded to that integrated vehicle health monitoring system.
Okay, but who receives those data?
So those are downloaded after mission day, as I mentioned before, by the operational units, and then they're uploaded to the cloud so that we can access it as an Army enterprise.
Okay, so at a higher level, the Army monitors those data?
The Army has access to it at a higher level, yes, as well as operationally.
Could those data be used to determine if battalion helicopters are exceeding the maximum altitudes on the DC helicopter routes?
Yeah, so the information that's recorded, so you have radar altimeter that's recorded, but you don't have terrain being recorded, which you would need. The recorded pressure altitude out of the system, it's very difficult to map the recorded pressure altitude to the pilot's barometric, what the pilot's actually physically seeing. So the recording in the HUMS system is not recording from the pilot's altimeter the way the transponder is. You're recording from a transducer that's on the same static line, but not connected to that instrument. So although they have some of the same errors, the instrument error that's in the pilot's instrument and the error that's in the transducer recorder path, those are different sets of errors.
Yeah,
and so in some cases, when those errors are close to each other, you get good agreement. And in some cases, when those errors are not close to each other, you get significant disagreement. But unless you have a reference measurement, you can't parse that out.
Yeah, I'm not asking about comparing the two types. What I'm asking is, does it contain, it sounds like it does record radar altitude. Does it record position?
It doesn't record latitude and longitude. Is that what you mean by
Yes.
position? No, but it does record the parameters needed to reconstruct the flight. However, you do need a known data point. As our NTSB friends did here, they knew the data point that we took off from on on the flight, and so they were able to reconstruct the May 15th flight from that known data point. But it doesn't
Okay.
include absolute time or absolute position.
So it would require considerable analysis.
It would require considerable analysis and considerable note-taking on at least a known reference point.
All right, thank you.
Yes, sir.
No more from the technical panel. Chairwoman Hamady.
Thank you. We're going to go in the same order. Alpa.
Thank you, Chairman. The first question we have is for Mr. Cooper. If barometric tolerances were tightened, would Sikorsky be able to support modification to these systems used in rotorcraft, even if it required retrofits or redesigns to the pedostatic systems?
For which model?
For any. But specifically in this case, it could be, you know, the Lima or the Micro going forward, whatever it might be.
Tighten to what limits?
If they were just tightened, say, we'll give you a number, say, plus minus 50 feet or something for field elevation barometric altimeter checks.
For the Lima, some, again, because it's a compilation of errors, as has been stated, it would require changing out of the government furnished provided indicator. So with that indicator, there's some limitations as to where you can tighten tolerances. For the others, it is plausible that we could analyze requirements and determine alterations to the probes. So plausible, but again, we would need the exact requirements. It's kind of hard to provide an answer, you know, for just a broad.
Of course. But so you're saying it would be possible, but it would have to be analyzed.
Yes, and the configuration, like I said, the external storage support system configuration has a larger error, and you know, need to understand how that applies also.
Thank you. Next question for Chief Warrant Officer Lewis. In your opinion, should any considerations be given to using different helicopter model types and low altitude routes located in congested areas?
As I stated before, I've flown the different variations that the Army has of the Black Hawk. I have not flown in the DC route structure. I have flown both the Mike and the Lima in low altitude, and based on my experience and not having flown here, I don't want to make a recommendation. I feel that's outside of my experience of which one's best suited to fly here.
Okay, understood. Thank you. That's all from Alpha.
Thank you, FAA.
I don't have any questions, ma'am.
Okay, thank you very much, NACA.
Chairwoman, we have no further questions. Our questions have been answered, and I'd like to thank the panelists today. Thank you.
Thank you. PSA.
Thank you. A couple operational questions real quick here. In your experience, Ms. Lewis, flying along, your co-pilot or instructor pilot voices a different altitude than you have of 100 feet. Is that any area of concern for you?
I would, if an instructor pilot, are you asking if they told me to adjust my altitude by 100 feet, would I do so?
If you call 300 feet and he calls you, I got you at 400 feet, would that be an area of concern for you?
100 foot of difference would not be a large area of concern. The first thing I would do would be to make sure we both had the same altimeter setting, and then address the situation going forward from there.
How much would it take to be a concern?
A couple 100 feet would be a concern in flight.
Okay. And I guess going back to the low levels, if you're on a 200-foot MSL route, would 100 feet be a concern then?
100 feet in what regard? 100-foot difference between the pilot and the co-pilot's altimeters?
Yes.
100 feet would still be, we would still have that 100-foot window, plus or minus 100 feet to maintain altitude.
Okay. Sorry, my next question. An example you were given by the tech panel You said if the bare altimeter was 160, radar altimeter displayed significantly higher, over 200 feet, you would continue to rely on the bare altimeter to conclude you were below 200 feet. Can you explain why you would fall back or use the bare altimeter as primary?
In my experience, if the barometric altimeter checks out good on the ground before I take off, and as we stated before, pilots generally, they're not out flying doing math between the barometric altimeter and radar altimeter, adding up altitude differences and considering that during flight. So as long as it was good on the ground before I took off, I would continue to assume that my barometric altimeter was accurate.
Okay. I have no further questions. Thank you.
Thank you. Sikorsky.
One quick follow-up question. Mr. Cooper, just to clarify, you said that the pitot probe location on the Black Hawk was determined primarily by Army operational and performance requirements for the Black Hawk. Is that correct?
No, I said that those feed into the consideration of its location, right? The available real estate on the aircraft, the required operational envelope of the aircraft, and what other equipment and considerations would normally feed into that selection. I honestly have to say in the late 1970s, I don't know why they picked the exact location, other than various other military products of that time, including those delivered to the Army from Sikorsky, had their probes in an above cabin location.
So I think you're also saying that other military aircraft at that time had probes in that location as well.
Correct. The CH-53, the H-3, and the S-54 crane, X-64 crane had those upper locations also.
Great. Okay. Thanks, Mr. Cooper.
U.S. Army.
Just one follow-up question, Madam Chairman. For Mr. Gant, we've talked a lot about altimeter errors and the deviations that are within the acceptable ranges. Are these unique to the UH-60 Lima, or is this consistent in commercial and general aviation across the national airspace?
It's across all fleet types. The physics doesn't change, although between the FAA and the military, we might have slightly different requirements. Maybe just by way of background, for transport category airplanes, the position air requirement is the same, plus or minus 30 feet per thousand, or per 100 knots, excuse me. And that's been in place since 1958.
No further questions.
Thank you. Can you pull up that chart again, Brian? Okay, so I will ask this question, Mr. Cooper. The model of helicopter that was involved in the collision, understanding that there are different requirements when you're ordering, is this model generally sold to other branches of the military?
There's UH-60 derivatives to the other branches. So first, you can explain those discrepancies, and if I could just talk through it just very quickly. So that delta that you see in those aircraft, if you take their how far those aircraft were from field elevation on the ground, and you assume that's a good approximation of its instrument error, and then you add the position error to that, and then you add the temperature effect, because on that day they were flying they were flying a warmer than standard temperature, which has, when you're trying to compare radar and barometric altitude, you have to correct for the temperature. So there's 36 feet of that roughly is a temperature effect. But so for those aircraft, if you take those standards, and I apologize, I'm flipping through my notes to get the exact numbers on the aircraft, but I have them for all the aircraft on that test. So for example, ma'am, so for aircraft number 1, it was 45 feet low on the ground. Mm-hmm. The position error adds 7 feet low, and then the temperature adds 36 feet low, which is 88 feet, which is close. So what you have is a case where you have 3 different effects all in the same direction. Correct. And then for aircraft
For the second aircraft, the one that was ESSS.
Those are the ones I went through before. A lot of those I went through before.
Yes, ma'am.
And then there are differences, obviously, from this chart in the allowable errors in the instruments, or in different components, correct?
I'm sorry, ma'am, say that again?
The chart. Some of those stack up, too.
Yes, ma'am. So some of those do. So the static system, the first two you see there are position error.
Yep.
One is military, one is civil. And then in the barometric, so for example, the scale error is the aneroid capsule error.
Okay,
Oh,
can
sorry.
I don't need to go through all of these.
Yes, ma'am.
We've already gone through all of these. The question I'm asking is you have a difference of 80, difference of 90. I understand there's temperature fluctuations. I understand there's allowable instrument error. What I'm getting at is, would you be concerned if this midair collision didn't happen and you knew, you had 75 feet of separation between the glide slope and the east bank of the Potomac?
Yes, ma'am. I'd say prior to this incident, that would not, I don't believe, have concerned me significantly. Understanding the vertical separation that existed in this case, yes, that would concern me.
Can I ask one more question? Was there at any, does anyone, and I'm going to ask everyone to answer this question, were there any efforts by the Department of Defense or Army to get helicopter Route 4 back in place after the Secretary did the work, thank you, of taking it off the map?
I'm sorry, ma'am. I don't know. That's not a
Does anyone else
area of
know?
my expertise.
I don't know either, ma'am.
I don't know, ma'am.
FAA, Sikorsky. Okay, thank you. Member Graham? Member Emma? Does the technical panel have anything? We've got time.
No, ma'am, we're good.
Okay, then we're going to go ahead and break for lunch. We will be back at 2:15. And just a reminder for the staff, lunch is served upstairs for all you all involved with this hearing. Thank you so much.
1, 2, testing, 1, 2. 1, 2, 3, 4, testing, 1, 2, 1, 2. 1, 2, 3, 4, testing, 1, 2, 3, 4.
She's coming down. Give me.
You have to move it?
Yeah. Or would you rather?
Why did they just? How are we gonna do all that shit when?
It'd be too complicated. Yeah. To move the whole camera.
Is he just gonna hold it?
So yeah, are you able to just?
I'm gonna pull the otter. Mine's not working. I'm just gonna use whatever you want.
Okay, yeah, that's fine.
Why didn't they just have her come? Why did they have? I mean,
I don't.
Where the pool camera? You guys should have been around this here. Why did they have to do it over here?
So she's standing there. I'm gonna ask if she can stand. I mean, can she stand right here? Excuse us. Watch your legs.
Where you need me to be? Where you want to be?
I was just trying to get.
I mean, you're.
I just dodged.
Well, I did some work.
You can stand next to me.
You ready?
Give us a 1 minute. 1 minute.
I should have gone to Dr.
She's standing here, right? Does she have a wireless mic to wear, or are you going to boom it?
We have
You go ahead.
this.
Okay.
This is the best we could do.
Which one is the pool cam?
The one right next to you.
Okay, so she should favor this one.
Yeah.
Yeah. So you want her this way? Yes.
Yeah, if she could.
Okay.
Yeah.
Okay. She's going to be turned this way. Yeah. Do you want to? You need to. Yes. Thanks. If I was gonna produce it, I'd say we should all move this direction. Right? Well, you're take one step to your left. No, you're fine.
Tom, is it okay if I go that way, or?
This one's the pool cam, right?
No. This one, the right.
Yeah.
Yeah.
We just don't want to get her in profile. That's all I'm trying to say.
Yeah, I'll have her turn this way. Turn towards the camera. It'll be okay.
Yeah. And then David, just let me know if you can hear it.
Take care of you.
Just let me know if you can hear this. Is it? Can you? Okay. Cool.
I appreciate that you're making me the center of the universe.
Yeah.
Ready? Yep.
Yeah.
Coming through.
Coming through.
All right, where do you want me to stand?
Right there.
You can stand here.
Right
and
here.
Look in this camera. Yeah.
Okay.
Chris, square it up. We can, hang on a second.
Where is? There you
Hi.
are. Hello. Hi, David. Hi. Hello, everyone.
Hello. Is everybody ready?
Pete.
Are we rolling? Yes, we are. Chris Van Cleet from CBS News, go ahead. Okay.
Wow, that is so generous. Go on.
I mean, what is your, after what you heard today, your level of concern about whether or not those helicopter pilots really had any good idea how high they were flying?
I am concerned. There is a possibility that what the crew saw was very different than what the true altitude was. We did testing in May that shows concerns with the altimeters, the barometric altimeters on the UH-60 Lima. So we are concerned, and it's something we have to continue to investigate.
How significant is 100 feet in this circumstance?
By the way, you don't have to look at the camera.
Okay,
You can look
thank
at
you.
me.
He told me to.
No, I don't know where that guy came from. We've never heard of that guy.
Okay, thank God.
How
Okay.
significant is 100 feet if the helicopter was telling them with plus or minus 100 feet their altitude? How significant is 100 feet in this case?
It's significant in this case. Helicopter Route 4, which went along the Potomac, in that area, we calculated that the margin of error was 75 feet from the glide slope at the greatest part of the glide slope to the east bank of the Potomac. And then it goes down from there as you go towards runway 33. So a 100-foot difference is significant.
Bottom line is the helicopter pilots thought they were flying at a higher altitude than they were, and their altimeters may have been misleading.
It's possible, and that's why we're asking these questions.
Was it appropriate for regulators to allow that type of variance given how crowded the airspace was?
Which regulators?
The regulators allowing for the
FAA
variance.
or Army?
The Army for allowing the variance.
So the Army's policy is plus or minus 70 feet.
Right.
The FAA's is plus or minus 75 feet. Over time, you have some changes in the altimeters. When you pick up significant discrepancies, you should put that into maintenance. With this situation, the bigger concern is the route itself and the design of the route, which we'll get into on panel 2. And now that they know there's a concern, why aren't they testing the rest of the fleet and the equipment? That I don't know, and they're only testing this specific model with the fuel tanks on the sides.
So, Chair, speaking of airspace design, you had asked in the panel just now if Secretary Hegseth and the Army had asked to sort of reclaim flight privileges around Route 4. Folks didn't know on the panel. Do you have some sort of indication that there was a request made and then it didn't get filled? What is your understanding of that?
I'm just asking the question. Yeah, just asking the question.
Name an affiliation and raise your hand.
Pete.
How big of a deal are these findings that there were sort of baked-in errors in the altimeters on the Black Hawk when you consider the fact that the margin of error between the approach path and Route 4 was only 75 feet? How big of a deal is this finding?
It's significant. And we're not just talking plus or minus 70 feet. What you heard from that panel is all these components have allowable errors, which are additive. So it could be 70 plus 20, plus 25, plus another 20. And when you're a pilot, once you are on the ground and you know your field of elevation is 45 feet, and you can confirm, okay, am I within plus or minus 70 feet for the military, plus or minus 75 feet for civilian pilots? You're not questioning as you're moving through the airspace. You're not sitting there and looking at your barometric altimeter going, okay, let me do some math and figure out if that's right. And as you heard from one of the panelists, she would be using over that portion of the Potomac River mean sea level route, she would be focused on her barometric altimeter.
How much of a factor was it how much of a contributing factor was the fact that they were wearing night vision goggles?
So we're going to get into the night vision goggles in panel 3. You're going to hear a lot more about that tomorrow. Allie.
Thank you. Allie from Bloomberg News. I had a question. You already issued urgent safety recommendations regarding the routes around DCA. Would you consider safety recommendations regarding the altimeters before you release the final report?
That's a great question, and that is exactly what our team is looking at right now. There is one thing I do want to highlight. I think some are very quick in the public, and I'm sorry to say this, but also the media, to jump on pilot error first. This is why we go broad as the NTSB. I've said from the beginning, we look at man, machine, and the environment in which they're operating. And that environment in which they're operating, we're not talking about literally the weather. That's part of it. What we're talking about is also safety policies, safety procedures. What are the systemic safety issues? So it's always easy for people to focus on there was a pilot error here. We don't know. We're going to look. But it's possible there was zero pilot error here.
Do you think that the Army is taking this seriously enough? It sounds like in some ways they were playing this kind of fast and loose when it came to these tolerances, when it came to altimetry and barometric pressure. Do you think they're taking this seriously enough?
Well, I think those are a couple of different questions in there. I do think that the Army is taking this seriously. However, I don't think anyone did the math until the NTSB did the math to show there was only 75 feet of separation at a critical point on that route circling to runway 33. And that's significant. My concern is, where else in the national airspace does that exist where there are charted helicopter routes? Has anyone else done the math on runway approaches? You're going to hear a little bit more on that through the course of the investigative hearing. With that said, let me get back to one of your questions. Am I satisfied with their responses on the actions they're going to take? Is that what you're asking? Nope, I am not. I am not satisfied with what I heard in this panel. I'm hoping to hear more in the next panels, and perhaps some other panelists, for example, the commander who leads the 12th Battalion, might be able to tell us that they are taking additional measures, and he will be testifying on the next panel. With that said, they are very focused on the UH-60 Lima ESSS with the fuel tanks on the side. They are not focused on the other ones where we also had determined as part of the testing that there were errors. And I will say, is this an issue beyond just the Army, which is why I asked if this model was sold beyond just the Army and in civilian purchasing.
The fact that you had at least one panelist, when asked, would the Army accept recommendations, said, we'll have to review it. Is that concerning to you?
Whether they'll accept our recommendations?
Your recommendations, yeah.
I think they'll accept our recommendations. My hope would be, since that we're working so closely with them in this investigation, that they will then implement those recommendations. That's my hope. I will tell you, I have had, while I'm tough, I have had great discussions with the Secretary of the Army, and we will stay in touch, and I'm hoping as we move through this that we can work together to get some of those recommendations all of our recommendations implemented, but what I mean by some is the ones that are applicable to them. David, and then somebody asked a question over here that we'll go to.
Dave Sherrodson from Reuters. So can I ask, is the issue, you think, the need for more testing, a broader fleet of aircraft beyond the Army? Is it about disclosure to pilots, or is it about a specific fix or update to the altimeters, either in the Black Hawk or other aircraft?
So that is analysis. And so we will look at that as part of our investigation. With that said, my concern, and I can speak to my concern, is should you be doing testing beyond this? How do we communicate beyond the Army? How do we make sure that you get from big Army to people on the ground? Are they expected to look at manual updates? How long do those alerts take? How long do those updates take? Are you going to phase out the Limas faster and bring in the mics? And then we'll go here.
Thank you, Chair. From Spectrum News. This obviously will take time to get the results. In the meantime, pretty terrifying for a lot of people that fly. Are they safe right now?
Aviation is incredibly safe, and I know I keep saying that. There are every day we see something in the news, but if you look at the numbers, the number of accidents, the number of fatalities, the number of injuries, they are significantly lower than, say, on our roadways, where 95% of transportation accidents occur. With that said, it only takes one, and we saw that here. So I can appreciate that concern. I sympathize with that concern. And that's why we're here. That's why we're doing this work, because we never want it to happen again.
Last question, Oriana.
Ariana with Politico. One of the reports in the docket suggested that there was concern over Route 4 and that the FAA and the DC Military Working Group was going to look into it and possibly create a new pathway. Do you think the FAA was short-sighted in not deviating and creating a new pathway? And should that have moved forward?
Ariana gets the first question after panel 2, because that's exactly what we're going to get into.
Thank you very much.
No, I commit to that.
Okay.
Thanks, guys.
Thank you.
Thank you.
Means we have to stay till 7.
I guess I
All of your
Turn off. You need to turn off your order.
I'm good. How are you?
Good, I'm going to go eat.
I just had I'm not recording.
Okay. Yay! I'm gonna try to get a note out on this gaggle. Do you want to take my order and get lunch what do you for want? anything that's not meat? So either seafood or veggie.
That's what I understand.
Okay. Anything that's like not meat. If we went to, there's like that bowl thing. Okay. So anything that's like either seafood or veggie. Okay. Not meat. Okay. Is that okay? Yeah, that's fine. Yeah. I'm gonna get David something. Yeah. Okay. Yes, I'm gonna go crazy. Okay. Thank you. Wait, also my name. Yeah. Thank you. Appreciate Pat it. said it looked good. It's pretty good. Okay, yay. Did you say if it sounded okay? I'm assuming. My You arm, had like, the fatigue? mic there, so I'm not worried about audio. Honestly. Okay. I was more. Great. Okay. Let me share this with you. Yes. Thank you. Yeah.
I'm not sure why he did that, but yeah, so that I did put a stop to, but where they are, that's, I don't want to. I will tell you though,
Right.
So I think the larger scale would be very civilian that want to require some radar, so you don't have to have or civilian can't fly in corridor. I know, exactly. We try. We gonna do it. It's gonna come anyway.
Okay. Thank you so much for bearing with it.
We were going to start at 2:15, but there's a really long line to get into security, so we're going to give it a little bit more time so people can get through. All right, we're going to go ahead and get started. And as we go into panel 2, Mr. Banning is going to provide a summary of the accident just to get us back in, since we've been out for an hour, back into as we go into panel 2. Mr. Banning.
As you saw in the animation, about 2 minutes before the collision, DCA Tower contacted Pat 25 to inform the crew of Flight 5342's location. At this time, the aircraft were about 7.5 miles apart. Flight 5342 was just south of the Wilson Bridge, and Pat 25 was over the tidal basin. Pat 25 stated that they had traffic in sight and requested visual separation, which the tower approved. 15 seconds before the collision, DCA Tower contacted Pat 25 a second time and asked if they had the CRJ in sight. At this time, the aircraft were about 1.25 miles apart. Based on information obtained from the CVR, the crew of Pat 25 did not hear the controller's instructions to pass behind the CRJ. Pat 25 again stated that they had the aircraft in sight and requested visual separation. The controller approved. The collision occurred about 8:47 and 59 seconds p.m. Eastern Standard Time. At the time of the accident, one controller at DCA Tower was managing both airplane and helicopter traffic. During the final 2 minutes of the accident flight, the controller spoke to 6 different aircraft, including Pat 25. As mentioned in the animation, all aircraft could hear the controller, but helicopters could only hear other helicopters on their frequency, and airplanes only other airplanes. Air traffic control procedures will be discussed as part of Panel 3. At the time of the collision, Pat 25 was in a near level attitude at an altitude of 278 feet and a ground speed of 90 knots. Flight 5342 was lined up with runway 33 and descending at a ground speed of 110 knots. At the time of the collision, the airplane was in a slight left roll and the elevators were deflected to near their maximum nose-up travel. The helicopter's air data systems and altimeters were discussed in Panel 1. DCA Class B airspace contains a high volume of helicopter activity that includes local and state law enforcement, all branches of the military, Homeland Security, the Federal Bureau of Investigation, the National Park Service, and medical transport. The volume and complexity of mixed operations required letters of agreement that outline specific procedures. Helicopter Route 4's ceiling was 200 feet. However, helicopter operators were encouraged to fly above 100 feet for noise reduction. Route 4 ran along the eastern shore of the Potomac River, but did not have defined horizontal edges. The runway 33 approach path was located over the Potomac River for a distance of about 4,100 feet. Runway 33 has a 4-light precision approach path indicator, or PAPI, that provides a 3-degree glide slope to the runway. At an altitude of 200 feet over the river's eastern shore, a helicopter would have about a 75 foot of vertical separation from an airplane on approach to runway 33. Panel 2 will discuss the airspace surrounding DCA and the helicopter routes. Flight 5342 was equipped with Traffic Alert and Collision Avoidance System, or TCAS. The flight crew of Pat 25 was equipped with iPads with the ForeFlight application installed, which had the capability of displaying aircraft that were radiating Automatic Dependent Surveillance Broadcast, or ADSB, out. ADS-B is a method of aircraft surveillance that can be used by air traffic control and other ADS-B in equipped aircraft. PAT 25 was not transmitting ADS-B data at the time of the collision. However, both aircraft were equipped with transponders and tracked by radar. Collision avoidance technologies will be discussed in panel 4. Multiple data sources were used to create the following images that depict the aircraft flight tracks from various views. None of the images depict the nighttime conditions that existed at the time of the accident. This image depicts a flight track of both aircraft. The yellow line is the helicopter track, and the green is the airplane track. The yellow circle is the location of the collision. This view looks south along the helicopter's flight track. This image is looking northwest along the airplane's flight path as it approached runway 33. The yellow line is the helicopter's track, and the green is the airplane's track. The yellow circle is the location of the collision. This image looks southeast from the DCA Air Traffic Control Tower. The control tower is located in the bottom middle of the image, highlighted by the red circle. As a result of the accident, the NTSB issued 2 urgent safety recommendations to the FAA to prohibit helicopter operations on Route 4 when runways 15 and 33 were in use, and to designate an alternative to helicopter Route 4. Immediately following the accident, the FAA implemented temporary airspace restrictions around DCA. Shortly thereafter, the FAA removed the section of helicopter Route 4 between Haynes Point and the Woodrow Wilson Bridge. Additionally, the FAA prohibited the use of runways 1533 and 422 at DCA during specific helicopter operations in the vicinity of DCA. The United States Army directed the accomplishment of operational checks of aircraft transponders to include ADS-B out functionality. Panel 5 will discuss safety management systems, including midair collision risk in the National Airspace System. NTSB was notified of the accident on the night it occurred, and a GO team launched the next morning. The staff listed on this slide assisted in the initial response and/or are supporting the ongoing investigation. Member Inman acted as the agency spokesperson on scene. Parties to the investigation are Aerosonic, the Airline Pilots Association, the Association of Flight Attendants, BAE Systems, Collins Aerospace, the Federal Aviation Administration, GE Aerospace, International Association of Machinists and Airspace Workers, Metropolitan Washington Airports Authority, National Air Traffic Controllers Association, PSA Airlines, Sikorsky, and the United States Army. In accordance with the provisions of Annex 13 to the Convention on International Civil Aviation, the Transportation Safety Board of Canada participated in the investigation as the representative of the state of design and manufacture of the airplane. The accredited representative was assisted by technical advisors from Mitsubishi Heavy Industries and Transport Canada. Chairwoman Hamady, this concludes my presentation.
Thank you, Mr. Banning. And now we'll go to Dr. Bauer to please provide an overview of the panel topics and introduce the technical panel and witnesses.
Thank you, Chairwoman Hamady. The second panel will provide an overview of the DCA Class B airspace and helicopter routes. The panel will address understanding the airspace surrounding DCA Airport, both the ATC perspective and the operator perspective. FAA standards governing design of Class B airspace separation standards. History of the helicopter routes to include the requests, development, and approval process of the Baltimore-Washington helicopter routes with special focus on Route 4. Description of the Army's mission and tasking in the National Capital Region and their use of helicopter routes. Complexities of fleet mix and history of safety issues involving helicopters, both the ATC perspective and the operator perspective. History and activities of the DCA Helicopter Working Group and ADSB out. The NTSB technical panel, starting on my right, is composed of Mr. Brian Soper, lead aviation accident investigator for air traffic control. Ms. Sarah Lewis, aviation accident investigator for air traffic control. Dr. Catherine Wilson, senior human performance investigator. And Captain Van McKinney, aerospace engineer, helicopters. Witnesses for this panel are composed of the following individuals. From my left, nearest the board members. In the front row, Mr. Nick Fuller, Acting Deputy Chief Operating Officer, ATO, with the Federal Aviation Administration. Ms. Katie Murphy, the Manager of Visual Charting with the Federal Aviation Administration. Mr. John Stowe, the Acting Director for Policy and the Mission Support Services of the ATO with the Federal Aviation Administration. Colonel Andy DeForest, Commander of the Army Aviation Brigade with the U.S. Army. Mr. Clark Allen, Operations Manager of the DCA Airport Traffic Control Tower at the time of the accident with the Federal Aviation Administration. And Dr. Steve Kasner, an aviation human factors researcher and author and retired NASA Ames employee. In the second row, we have Mr. Rick Dressler. He's an aviation site manager with MedStar Transport of Metro Aviation Incorporated. Lieutenant Colonel Paul Flanagan, the product manager of Assured Airspace Access Systems with the U.S. Army. And Command Chief Warrant Officer David Van Vechten, who is a former standardization instructor pilot with the Army Aviation Brigade of the U.S. Army. Chairwoman Hamady, these witnesses have been pre-qualified and their respective experience and qualifications appear in the docket as exhibits. Thank you.
Thank you, Dr. Bauer. I'll now ask the witnesses to please stand. Please raise your right hand and answer by saying, "I do." Do you swear or affirm that the testimony you'll give in this hearing will be the truth? Thank you. You may be seated. As a reminder to the witnesses, you will remain under oath until the conclusion of the hearing. We ask that you answer the questions factually and avoid any type of analysis or speculation. Finally, please push the microphone button to talk and push it again when you're finished. I'm now going to turn questioning over to Mr. Soper.
Thank you, Chairwoman. Mr. Allen, could you please provide us with an overview of the DCA Class B airspace, and please include some of the most prominent complexities, challenges, and constraints from an air traffic control perspective?
Good afternoon. The DCA Class Bravo airspace extends out approximately 7 miles. It adjoins to Dulles Airport's airspace as well as Andrews Airspace. We receive helicopter traffic from Andrews, Baltimore, Dulles, Davison Army Airfield, and the local law enforcement and medevac hospitals. Some of the challenges associated with the airspace is the lack of airspace that we have, so to speak. There are multiple prohibited areas that we are unable to fly in. We have very specific procedures for fixed-wing aircraft and helicopters.
Thank you. And for Mr. Dressler and Mr. Van Vechten, I'd like you to respond to the latter part of that question as well, which was if you could share with us your most prominent complexities, challenges, or constraints for Mr. Dressler first from a non-military operator's perspective in the DCA airspace.
Thank you. For my perspective as a medevac operator, we're actually very privileged because in terms of priority, when we use the term medevac, we move everyone out of our way, including Marine HMX. For some of our other members, however, for the ad hoc DC helicopter operators group, that is not the case. So from a law enforcement perspective, we have several operators, whether that's U.S. Park Police, Maryland State Police, Fairfax County Police, Prince George's County Police Aviation, and all of them operate in an unscripted way, in a sense, because they don't fly from point A to point B necessarily. So their challenges are even greater than mine because I have an intended destination for every time my ships or one of my fellow medevac operators goes in. Our complexity is really, as Mr. Allen said, the airspace is very small, has very little room to maneuver, and we have prohibited areas that we have to avoid as well. Add in the final challenge is just the high volume of helicopter traffic in a very confined space.
Thank you. And Mr. Van Vechten, same question for you from the military or Army operator's perspective operating in the DC airspace.
Yes, we have the same challenges as Mr. Dresser addressed. The prohibited areas, and we're on specific routes that we are cleared through by ATC, or if we're in a zone, we're in a specific zone. So we must stick to these routes and zones as directed and cleared by ATC. There is a large volume of rotary wing traffic at low level, which is always a concern, and then the volume of fixed wing traffic in and out of Reagan Airport.
Thank you. Mr. Allen, back to you. When the helicopter control and local control positions are combined at DCA Airport Traffic Control Tower, do helicopters and fixed-wing aircraft share the same frequency, or do they remain on separate frequencies like when they are decombined?
They remain on separate frequencies.
And is that policy, or is that is there a reason for that that you're?
They're charted the helicopter frequency specifically, so the helicopter users are going to naturally contact the facility on that frequency.
Okay, so from an air traffic controller's perspective, are there advantages or disadvantages to having the helicopters and the fixed-wing aircraft on separate frequencies when it's combined?
Combined, it'd be subjective to each individual, but in my opinion, a positive would be it can help you prioritize your sequence of events or what you need to accomplish a little bit easier, having them separated.
Okay, any disadvantages? from an air traffic perspective?
Disadvantages, aircraft may step on each other utilizing two separate frequencies. You may miss an initial call or something of that nature.
Okay, thank you. And for Mr. Van Vechten and Mr. Dressler, once again, how about for yourself? For the Army operator's perspective, is there advantages or disadvantages to being on a separate frequency from the fixed wing operators while you're operating there?
Yes, sir, both. First, the advantages. I don't have to continuously hear all the fixed-wing traffic, which would tie up communication between the pilots in the cockpit. The disadvantage was it leads to somewhat of a lack of situational awareness because I'm only hearing half of the conversation. So, for example, when I hear tower transmit and they say Brickyard 1234, clear to land runway 19, I have to anticipate and wait for that fixed-wing traffic to say, Roger, clear to land runway 19, or else I could end up stepping on him. So as you initially enter the airspace, you have to pause for a few seconds to see if there's anybody talking that you may not hear on a separate frequency.
Thank you. And Mr. Dressler, for you.
So we are split among our community. All of the civilian aircraft carry two sets of VHF radios. And in that case, you could be listening to two frequencies at the same time. So many of our members dial up the regular tower frequency on one and monitor it, and on the other, we'll be up on the helicopter frequency. That depends on the pilot choice. The disadvantage to that is we also have a helicopter air-to-air frequency that we can communicate and deconflict amongst ourselves. And if you take that one out of play, you have no way to talk to anyone else. I prefer the simulcast same frequency model because I do like to hear all of the commercial traffic at the same time, so I can formulate my plan around that as well. I think the disadvantage is clear. It's a very, very, very busy airspace, and for all of us to be waiting in order to make a radio call without stepping on someone else is the massive disadvantage that I don't think there's a solution other than a split terminal.
Excellent. So I'm glad both of you mentioned stepping on, and just for context, when we say stepping on, that's, I'm assuming, and you can correct me if I'm wrong, but when two people are transmitting at the same time simultaneously and one essentially steps on the other and one person or both people's transmission might be partially or wholly blocked out, correct?
That's exactly correct.
Okay. So along those lines, is there any way, and this one is for Clark, I'm sorry, Clark, is there any way for an air traffic controller to know if they were simultaneously broadcasting or had stepped on, or somebody had stepped on a frequency where an aircraft might not be receiving their full transmission? Are you aware of anything? Is there a side tone? Is there something that occurs that lets a controller know that, or is it just potentially lost transmission?
If the controller was given an instruction that would have required a readback and they did not receive the readback, they could assume that it was stepped on or the aircraft didn't hear it. But if it did not require readback, no, there would be no way for them to know.
Okay. And in your experience at DCA, is there a notable difference in the quality of radio transmissions from military versus non-military helicopter operators?
Yes.
Okay, and could you kind of elaborate on that for us? Give us an example.
Yes, among the medevac and law enforcement community, they operate newer aircraft with newer equipment. Like Rick had said earlier, they have dual radios where other operators are using other aircraft that are perhaps more dated and maybe only have a single radio versus dual radios that can impact communication.
Okay, so from along this same vein here, are there any particular operators that operate regularly within the DCA Class B airspace or even type of helicopters that stand out to you as exceptionally challenging when it comes to communication quality?
We've had trouble in the past with the Air Force and Army.
Okay. And does the helicopter control position at DCA have a UHF frequency available for use if requested by military pilots?
Yes, there is one.
Okay. Have you ever known or have you ever experienced a military pilot to request a UHF frequency since you've been there? Or?
It's maybe occurred less than a handful of times.
Okay. And Mr. Van Vechten, for you, along this same thread here, are you aware of any feedback or have you had flight crews report similar concerns that they've received about the reception quality from their aircraft while flying here or anywhere around the area?
No, sir, I have not.
Okay, thank you. I'm going to shift modes just a little bit here to helicopter route history and the development of those, and with a little bit of a focus on Route 4 as well. So, Mr. Stowe, could you provide us just a brief explanation of what helicopter routes and helicopter zones are, if you can? If this is out of your area, please let me know. What is their primary purpose, and how do they fit into the airspace structure within the DCA Class B airspace specifically?
Absolutely. I would specifically reference Air Traffic Order 7210.3 when describing the helicopter route chart program. Chapter 12-4-1, helicopter route charts are graphic portrayals of discrete and or common use helicopter routes and or operating zones located in high density traffic areas. Their purpose is to facilitate helicopter pilot access into and egress from or operation within charted areas. That's a direct quote, but generally speaking, these charts facilitate reduced or easier controller-pilot communications. There's a level of understanding when a helicopter pilot were to check in with a controller, reporting a route, what the expectation is, where they would be flying, where they would be ingressing and egressing. Overall, it helps with efficiency and streamlining traffic flows as well.
Okay. So along those lines, this for Ms. Murphy or Mr. Stowe, we heard earlier in Mr. Banning's presentation that the helicopter routes had no defined lateral boundaries. Could either of you explain why that is?
I can take a shot at it. So the helicopter routes are non-regulatory. They are merely recommended paths. It is expected that all pilots remain in contact with air traffic control while flying. As for the lateral boundaries, what is currently charted is nothing more than a symbol used to showcase the routes pictorially so that they look good, if you will, cartographically.
Okay, so how would, looking at those lines on a helicopter route chart, how do I know if I'm in compliance with that route from a lateral standpoint, if it has no lateral boundaries and it's just generally the area?
So I guess to build on her response, and I think to lead into the question, the charts are recommended for the purpose of streamlining pilot-controller communication and expectation, so the controller doesn't have to continuously assign a route. Knowing that there's no prescribed lateral boundaries and there's general recommended altitudes unless the controller specifically assigns via clearance or operating instruction to maintain an altitude or comply with the published altitude, it would be incumbent on the controller to ensure that they're monitoring the route of flight and address any conflicts and maintain or ensure a proper separation.
Okay. Mr. Stowe, continuing with you, would your office have been consulted in a request for establishment of helicopter routes that transition the DCA airspace?
So the local air traffic manager is responsible for initiating updates, changes, or initiating new helicopter route chart establishment. They would generally work with the Mission Support Services service centers who would support establishing a local work group or task force, as it's referred to in the 7210.3, which would be comprised of local operators, and then a lot of local coordination work would be done, and then that would ultimately be passed off to the charting office to actually publish the charts.
Great. Mr. Fuller can thank you later because you just answered his question. Mr. Allen, are you aware of DCA Air Traffic Control Tower management and or the bargaining unit if they had any input or involvement in the development of the route structure at DCA Airport Traffic Control Tower? Now, I think it's been in place for quite some time, so you may not have been working there when it was, but do you have any awareness if the facility did have input on that?
Whenever we made helicopter route and zone changes in 2023, I believe it was, it was facility driven between the bargaining unit and management.
Okay. Mr. Fuller, is there a requirement for the Baltimore-Washington helicopter route chart to be reviewed at any specific periodicity by any entity?
Not that I'm aware of.
Okay. Ms. Murphy or Mr. Stowe, are you aware of any periodicity requirement that he might not be aware of for a review of those charts?
I would refer, since I have it in front of me, to the 72.2.3, again, same paragraph, that would require annual review as the responsibility from the air traffic manager for reviewing helicopter route charts.
Okay, so what would be the expectation of that review? Would that be documented in some form other than we conducted a review and everything remained the same, or would they fill out a report or some sort of correspondence through their hierarchy chain of command?
I don't know I'm not aware of a specific requirement. I would generally only be speculating or assuming that they would document it in some manner.
So, Ms. Murphy, would your office receive confirmation, let's say that facilities have conducted their annual review of their charts, their applicable charts, and then you would monitor that, or not monitor it, but you would see that or not?
No, Aeronautical Information Services only receives communication if and when a change to the chart is requested.
Okay. Mr. Allen, were you ever involved in conducting any of these reviews, assisting the air traffic manager potentially of the Baltimore helicopter route chart?
When I was a member of the helicopter work group, we did routinely review it, and that's how we came up with the changes that were implemented in 2023.
Okay. So I have to ask, I think I had it for later, but we're right at a point where it's probably a good point to ask this. Helicopter Route 4, the helicopter route in question in this event, do you recall either as part of the helicopter working group, as part of annual reviews conducted, or part of local safety council, anything that identified Route 4 as being problematic or conflicting with regard to your traffic flow at DCA Airport Traffic Control Tower?
Yes, we had those discussions.
Can you elaborate on that just a little bit?
When we met with the larger user groups of the airspace and discussed different improvements, ways we can make the system safer, more efficient, it was brought up with several different options, either to eliminate a portion of Route 4, move Route 4 over to 295 in Maryland, and both of those options we were told we were unable to do due to continuity of government operations or security.
Okay, thank you. So for Miss Murphy, do you have a history of the development of the route of the helicopter route structure there? Like when they were established, these routes that transit the Class Bravo airspace at DCA?
Well, without records in front of me, I can detail a little bit. Route 4 appeared in totality on the first edition of the Baltimore-Washington helicopter route chart effective February 13th, 1986. It was largely unchanged until 1991 when air traffic added a compulsory reporting point at the Wilson Bridge. After that, there have been no changes until this early spring, post-accident, and we continue to work.
That is helpful information. So along with that, at its inception, Do you know, or are you aware, by looking at that back then, did DCA have a runway 1533 at that time?
I do not know without the chart in front of me.
Can anybody up there answer that question? Mr. Allen, do you know back that far if that runway had always been in existence there?
I wouldn't know that.
Mr. Fuller?
I'll take an IOU to get back with you and answer on that.
No problem. Okay. So my question would be, knowing what we know today with that route structure where it was there, would there have been an expectation that there would be consideration given to its proximity of the approach corridor to 33 and the departure corridor to 15 in this case?
I can take a shot at it. I think consideration of proximity and local traffic flows, patterns, or what the needs of air traffic are, is going to be highly site-specific and dependent on traffic flow densities within the airspace that may change over time. Not having specific knowledge of DCA, but broadly, the helicopter charts aren't specifically established to maintain separation. That would still rely on air traffic control to actively separate aircraft.
Which brings me directly to my next question. Was Route 4 procedurally separated from the approach path to runway 33 or the departure corridor from runway 15?
To my knowledge, no. I would have to defer to local air traffic as to what the consideration was when the routes were established or amended.
Understand. Mr. Allen, what's your understanding of that?
No, it is not procedurally separated.
Do you believe that the controllers, the control workforce at DC Airport Traffic Control Tower has a similar understanding across the board that that is not a procedurally separated route?
I can't speak for everyone, but I would say a majority do.
Okay. Mr. Dressler, did you or any of the other helicopter operators that you've been working with in the group there have an expectation that Route 4 was procedurally separated from fixed-wing aircraft there?
No, we did not have an expectation it was procedurally separated, but our group rules of the road are pretty explicit in saying that we would never fly underneath an aircraft on final.
Okay. And Mr. Van Vechten, same question for you. Did the involved Army helicopter unit have any belief that Route 4 was procedurally separated, that if they were on that, they would be separated from fixed-wing traffic arriving 33, departing 15?
Yes, sir, I did.
You had that thing, and was that a similar belief across the unit?
Yes, sir. Following the incident, I contacted many of my fellow co-pilots that were there, and everybody had the same assumption that we were not allowed to cross the departure and approach path of 1533 while on Route 4. We were always told to hold at the golf balls down by the sewage treatment plant just northeast of Wilson Bridge or at Haynes Point, which I'd done 100% of the time when I was on Route 4 and 3315 was active.
Okay, so that may have confused a little bit. So so the belief there would have been that you did not believe it was procedurally separated. Because procedurally separated, just so we have an understanding, when I say procedurally separated, meaning if you fly that route at the altitude you're supposed to and an aircraft flies that approach the way they're supposed to, they will have appropriate standard separation and will miss each other if they are both flying their prescribed route, right? That would be procedurally separated. What you are saying is that you believed there to be a mitigation in place. You were aware they were not procedurally separated and that without a clearance from air traffic control, you would either hold at a particular area or request clearance to proceed across.
That's correct, sir. When I say procedurally separated,
Yes.
I meant that a procedure prevented us from crossing 1533
Very
while
good.
on Route 4.
I should have prefaced that with a definition there of what I was saying. So thank you for that. Mr. Allen, do you know if consideration was ever given or there was ever a request made or a proposal made, I should say, for an alternate north-south routing to either replace Route 4 or alter Route 4 to help alleviate the conflict of where it crosses the Route 33 approach corridor?
There was discussion, like I previously mentioned, to either remove a portion of it or move Route 4 over towards the east, towards 295. But the zones also allow for north-south flow.
Do you know how high that proposal made it in the request chain at all? Did you receive any feedback or disposition of that proposed?
I don't know how high it went.
Okay. Mr. Fuller, do you have any awareness from your office? Did that ever reach your level?
No, no proposals to remove Route 4 ever reached my level. I looked back through the system service reviews and the corrective action plans developed for the facility, and there were no records of a request to remove Route 4.
Okay, thank you. And Mr. Allen, one last question for you in this area, and then I'm going to pass it along. Who, from your experience working at DC Airport Traffic Control Tower, who is the primary user of the helicopter routes inside the Class Bravo airspace? Is it a real mix? I guess what I'm asking is this a mix of a lot of helicopter operators, or is it primarily the military using the routes? How is it split up there? Or is it just a total mixed bag?
I would say a majority would be the various military branches with some of the other users mixed in at a lower level.
And how about Route 4 that was being used that day? Who is the primary user of that, or users?
It would be the military.
Okay. All right, that's all I have for now. I'll pass it along to Van.
Okay, I'll be asking questions about helicopter operations in and around the national capital region. Colonel DeForest, could you describe the Army's mission in and around the national capital region?
Absolutely. And before I do, Chairwoman Homendy, Member Graham, Member Inman, families in the room, and those watching online, on behalf of the Army Aviation Brigade, as a husband and a father, I want to express my deepest condolences. This is something we think about every day, and your memory of the loved ones we lost are forever in my heart. The Army Aviation Brigade, specifically 12th Aviation Battalion, provides continuous, responsive rotary wing support to senior military and government leaders in the National Capital Region to enable continuity of government and continuity of operations missions. On America's worst day, our nation's leaders trust the 12th Aviation Battalion will respond on a very short notice. It's a no-fail mission that requires regular, realistic training, national airspace system, and that's to maintain unit readiness for when the unit is called upon. Today, right now, 47% of our aircrew members in 12th Aviation Battalion are on mission lines waiting for that call. We're privileged to operate in the national airspace system in the National Capital Region. We have a very unique mission. We attract some of the very best across Army aviation, and we hold ourselves to a very high standard. Our mission involves both the zones and the majority of the helicopter routes in vicinity of DCA. And we see the routes and the zones as a risk reduction tool. They provide known altitudes and locations to deconflict with other aircraft. And I just want to be clear, there's others that perform a similar mission. So we view the helicopter route structure as a risk reduction tool.
So do you consider the use of the routes essential to the mission?
Yes, I believe they are essential to accomplishing our mission safely.
And can you describe any types or categories of operations along those routes that are commonly used?
Now, could you be a little bit more specific on types of operations along the routes?
So you have mission essential operations, training operations, non-mission essential operations. So would all those be considered essential?
And for the training, so the mission rehearsals that we do conduct, and I think we understand familiarity, aircrew familiarity of the region, so knowing the altitudes, the terrain, the buildings, the hazards, that is absolutely essential. And those routes provide predictability to our aircrews. So for our mission rehearsals, yes.
Thank you. This is questions for Mr. Dressler. Could you describe helicopter operations, non-military helicopter operations in the NCR, National Capital Region?
Certainly. Since 2001, all of the civilian helicopter operations are mission only, and they're comprised of law enforcement with various entities I mentioned, U.S. Park Police, FBI, Metropolitan Police Department, Prince George's, and Fairfax counties, to name the law enforcement I can think of, and then all of the medevac operators. So medevac is easy to explain, that we're transporting critically ill patients, usually from tertiary treatment facilities outside of the city, to some of the world's best trauma centers, including Washington Hospital Center, George Washington Hospital Center, and Georgetown. And the transport of those patients into those critical areas in a very ground traffic laden environment is a lifesaver day in, day out. On the law enforcement side, the law enforcement officers perform both patrol, and then they may, in fact, transition into operational status during an active pursuit of some kind, generally speaking, a priority call of a crime against person, meaning homicide, carjacking, etc. And those operations have no specific destination in mind. They're merely performing those orbits or those pursuits while in flight.
So for those common non-military operations, is it considered the helo routes as essential for completion of those operations?
Yes and no. By and large, non-military operators use zones, and there are a number of reasons for that. And one of those reasons is to deconflict with military operations who are primarily on routes. In the case of medevac, we may not know exactly where our start point is, and there may not be a convenient route to get a critically ill patient where they need to go. In the case of law enforcement, these were originally in the 80s called police zones, and the reason for that is because other traffic would be confined to routes, and police would have the ability to patrol in those zones. So I think it's a mixed bag. Some of the routes, including two that were deleted after January 29, I would say are essential to our operations because they provide the safest way to transit east-west in the route structure. They're predictable. Zones, one limitation of the chart is that the altitudes are maximum altitudes. So, for example, a zone altitude might be a maximum of 1,400 feet, and that doesn't afford as much predictability as some of the routes themselves are very altitude specific. Route 4 along the Potomac is one of them at 200 feet, at the 200-foot cap. But if you could imagine then that a zone could be a maximum of 1,400 feet, so you might have a helicopter operating at 1,200 as a police helicopter conducting FLIR operations. You might have us at 1,400 feet. You might have others at different altitudes, and that presents a challenge in the zones.
And that deconfliction, is that done by ATC, the controlling agency you're talking with, or is that all visual or ship to ship?
It is, because it's Class Bravo, it is primarily ATC. All of us provide an initial request, which sounds like our route of flight. So we might ask for Zone 5 to RFK to Washington Hospital Center, for example. And air traffic control will clear us for that route. That's that efficiency portion that is really essential. It cuts down on our radio traffic and gives us predictability. in this airspace, I think I mentioned it earlier, that we have the ability to talk on air-to-air frequencies, but unlike other cities, because the Class Bravo airspace surrounds Washington, D.C., it's very, very challenging to deconflict ship to ship. Instead, you can't focus on more than one primary thing. Otherwise, it wouldn't be a primary thing. So focusing on the tower frequency, on the helicopter tower frequency as a primary focus because it's so busy, doesn't afford you much time to call another ship and deconflict. That is different than other cities, including Baltimore, and where you might very well say, hey, I'm MedStar 2 and I'm lifting off of shock trauma, and then other people in the area will be able to deconflict with you. So greater than 99% air traffic control.
Okay, thank you. And when operating, do the non-military operators have special considerations when deciding to use a route, one of the helo routes? Is there special considerations within the local operating area that helps you determine whether you to use the route or not?
I don't know of any other than individual company policies. So my company's policy after a near miss, unfortunately in 2017 with Black Hawk helicopters, my company restricted our ability to use anything between Key Bridge and the Woodrow Wilson Bridge. So we cannot use Route 1 or Route 4 because of the helicopter volume. We're also altitude limited. So by our operation standards, we cannot fly lower than 300 feet day or 500 feet at night. And so those are limiting factors that might vary company to company or unit to unit.
Thank you. Mr. Van Vechten, as a standardization pilot, what are the training standards for maintaining altitude on a particular route?
Pilots are expected to maintain their altitude plus or minus 100 feet.
If a helo route with a defined ceiling of 200 feet, would those standards apply?
Yes, sir. I mean, I don't think there's any expectation that we can maintain an altitude plus or minus 0. There's too many limiting factors. So again, talking to other pilots, I think the reasonable expectation is that being off on altitude by 50 or 70 feet, one way or the other, would not lead to a catastrophic event.
Okay, so for a ceiling altitude of 200 feet, 250 feet would be acceptable as a training standard?
No, sir. I mean, if a pilot is continuously above the altitude, they're going to try to correct. I'm going to make them correct. It's where they stay above it where it's a problem, but we call it bracketing, so a kind of above and below the altitude while you're trying to maintain a constant altitude.
Okay, thank you.
May I address that as well?
Certainly.
I hate to disagree, but at least on the civilian side, that is a hard altitude for us. We do not accept a plus or minus of 100 feet in the DCA route structure. That's maybe a commercial flight standard, but that is unacceptable and how none of our civilian members are trained in the DC airspace. So a 200-foot altitude or 300-foot altitude is a hard ceiling for us.
Okay, thank you. Mr. Van Vechten, could you describe the purpose of the annual proficiency and readiness test in the Army?
Sure. It's to determine a pilot's ability to perform the unit's mission.
And what could you go into a little more detail on what all that involves?
Yes, it includes the instrument flight evaluation, the standardization flight evaluation, a written exam, and a night vision goggle evaluation.
Okay. And is it common to conduct this evaluation at night on NVGs?
Yes, it is. The standardization flight evaluation does not give a mode of flight. The NVG, night vision goggle evaluation, obviously must be conducted under night vision goggles. The standardization flight evaluation, if conducted under the most demanding mode of flight, which is NVGs, will count for both evaluations, so you don't have to waste the blade time doing a daytime standardization flight evaluation and then going back out at night to do the same task under goggles. You can accomplish both at the same time.
Okay. Since we're talking about NVGs, can you estimate the percentage of night Army operations where NVGs are utilized?
Can you clarify, please? What
Just
you mean?
like, are NVGs normally utilized during almost all Army night operations?
Yes, ideally that would be the case. I would much rather be aided with night vision goggles than unaided, of course.
And is NVG crew proficiency important?
Yes, it's extremely important. Night vision goggles is the most demanding mode of flight, and so that's what we would train to the most rigorous standards.
Can you recall what the requirements are for that?
As far as annual,
yes.
It's 9 hours semi-annual per semi-annual period, 18 hours total, and you must fly 1 hour of NVGs every 60 days to be considered current.
Okay, thank you. And for people to help everybody understand the benefits and limitations of NVGs, could you describe what some of those advantages and disadvantages of using NVGs are as from an operator perspective?
Sure. First, the advantages, the quite obvious ones. Best visual acuity while unaided is 2200. So where 20/20 would be like good vision, your best visual acuity you're going to get while you're night unaided is 2200. So the ability to see is the number one advantage with night vision goggles. It amplifies light, allows us to see in darker environments, and provides better acuity for the pilots. The negatives, depth perception, obviously is much more difficult to judge because we have monocular vision, whereas right now I'm using binocular vision, so it's much harder to judge depth perception. It was mentioned earlier, the limited field of view, so approximately 40 degrees compared to roughly 180 degrees, what I have right now. But it's also, it's easy to confuse ground lights with aircraft lights. You can see through haze, which is an advantage initially until you're fully engulfed in poor weather, and then it becomes a disadvantage. So those are some of the advantages and disadvantages.
And what about being able to see aircraft silhouettes? Do you just see point lights, or can you actually make out the shape of the aircraft?
Well, it really depends on the distance from the aircraft. Normally, I'm not close enough to make out the silhouette of an aircraft. So they mentioned earlier about looking underneath your goggles. So as you're flying night vision goggles and you see a light that is potentially a hazard, it's common practice to look underneath the goggles to verify what it is, because you could very easily confuse, say, a vehicle passing on Wilson Bridge as an anti-collision light as it goes across, or a vehicle on elevated terrain making a turn. It flashes into your eyes, so you must visually acquire what it is. So you really can't see the silhouette. Our goggles have trouble seeing blue and green lights, so the right side of an aircraft would be much more difficult to see. A red light is much brighter, and then white lights obviously are bright as well.
And how are the crews trained to compensate for the more narrow field of view?
By scanning.
Could you explain that a little bit more, please?
Yes. So we have a saying: we cannot increase our field of view, but we can increase our view of the field. So as I scan my head from left to right, I kind of move my eyeballs from left to right inside the goggles, increasing my view of the field. We try not to get tunnel vision or get fascination fixation on an object. So we're constantly scanning to pick up different reference points to pick out objects in the distance.
And that's a common training technique?
Yes.
Okay. So this question's for Mr. Allen. From what you've heard...
Mr. Mechanic,
yes.
Can you hold for a second?
Certainly.
I would ask that witnesses put away their electronic devices. If you are communicating with your party tables, you should not be doing that. Please put them away. If your party wants to ask a question or get information to you, you can ask it during the Q&A period. Thank you.
Okay, this question's for Mr. Allen. From what you've heard regarding the use of night vision goggles by flight crews, would it benefit air traffic controllers to be trained on the advantages and limitations of NVGs?
Currently, air traffic control we don't get notified that they're using NVGs. We wouldn't know, as far as from an air traffic standpoint, operationally, what that would look like. I think we would need more input on their uses.
Would the knowledge of the NVG limitations affect how air traffic controllers handle the traffic?
Potentially.
Okay.
Can I add to that?
Certainly.
So it would generally be the expectation for air traffic that for Class B operations, all aircraft receive traffic advisory safety alerts, and air traffic provides separation services to all aircraft. We're also heavily dependent on see and avoid and relying on 91-113. I would refer to the 7110.65 Class B separation criteria for helicopter to helicopter would be that IFR or VFR helicopters are not separated from other helicopters. So it would be dependent on pilot see and avoid, independent of the use of night vision goggles.
Okay, thank you. I think I'll pass my time over to Dr. Wilson.
Thank you. I want to go back to something that Mr. Allen said when we asked about moving Route 4, if there had been any discussions about changes to Route 4. You said that the response you got was something to the effect of continuity of government operations and security. And then it piqued my interest, Colonel DeForest, because in the mission statement that you said, you mentioned continuity of government operations. And it made me think, was the Army, you or the Army, aware, or did you see any proposals that you were able to provide feedback on regarding changes to Route 4? It piqued my interest that the wording was very similar to what the response to DCA Tower was, and then the Army's mission. That's for you, Colonel DeForest. I apologize.
Okay. I thought it was for the colleague next to me. So that specific route is an option for our air crews, or it was an option. And when we look at our response times of our air crews in certain locations within the National Capital Region, so Route 4 was heavily used by our air crews on our mission rehearsals.
So my question was, were you aware of any proposals to make changes to that route?
The only proposal for a change that I'm aware of involves noise abatement, not necessarily lateral movement. So noise abatement was the only proposal that I'm aware of.
Thank you. Mr. Allen, you mentioned when we were talking about radio transmissions and some of the difficulty with some of the operators, you mentioned both Muscle and Pat, that you might have more challenges with the radio communications with them. Are there any other concerns or challenges when Muscle and Pat are operating in the DCA airspace that raise concerns for controllers?
I think additional concerns are they do conduct a fair amount of training missions. New folks arrive on base or maybe come up from a National Guard unit or something that aren't as familiar with the airspace. So being unfamiliar in a high volume, high complexity airspace naturally has its own challenges.
Mr. Van Vechten or perhaps Colonel DeForest, do you have a response to that or some additional information, insights that you want to share. Does that surprise you that there might be more concerns when particularly Pat is operating in the DCA airspace?
What I would add is our participation in specifically the DC rotary wing working groups. That has not been raised to our, at least the unit level, that there was a concern with the Pat call sign. And I'll hand it over to Mr. Van Vechten.
Yes, I was a member of the DC Helo Route User Working Group. Some of the concerns that were brought up were noise abatement was the main one. And then when police and MedStar are operating in the zones, just keeping military rotary wing aircraft out of the zones. That was a couple of the concerns that they brought up, because we know that when a police helicopter is in pursuit, both people inside the aircraft are probably looking inside or looking down in the street, and they're not looking outside the aircraft. So we avoided the zones that were active, and anytime Falcon, which is the DC Metro, was active in a zone, we would avoid those zones. But I was not aware of any requested changes.
Mr. Allen, going back to the proposal to make changes to Route 4, do you recall when that proposal was made?
We had attempted it when I was part of the helicopter working group in the 2021-2022 timeframe.
Okay, thank you. And was there a documented proposal that you recall?
Not that I recall.
Okay. Mr. Dressler, we've talked about concerns about certain operators in the DCA airspace. From your perspective, are there any operators that you feel cause concern for your operations?
Unfortunately, yes. And I don't take any pleasure. I'm a former Army aviator, and I'm a retired Air Force officer. And I don't like to say that that the Air Force First Heli is a concern, and I really don't like saying that 12th Aviation is a concern. But it was a widespread concern, and it was noted to the battalion commander previous to the current one in about 2022 or 2021 by a member of our group, that there was a significant issue with both training and attitude toward operations within the DC airspace.
And could you expand, so how did that affect your operation?
Well, when you combine that with our 2017 near miss, my company and the other operators in the area either curtail operations, or there's not much we can do when we have a medevac patient and we're trying to get a critically ill patient where we need them to go. But our best answer is to maintain extra vigilance. It's an extreme challenge, especially when those aircraft are not usually transmitting on ADS-B, and I can't see them on my traffic system, and all kinds of challenge inherent there. I think our best answer is extreme vigilance. I know in our company policy we fly as high as possible, so we'll take the maximum of any of the zone or route altitudes. And the air traffic controllers, we have a fantastic relationship with them and have always had that, where we can ask for something different. So if I need to ask for a deviation, and the same with all of our members, we're not bound by that, and they'll grant those requests whenever possible. The best answer I have for you is see and avoid, which is the basic tenet of every aviator on the planet.
Thank you. I'm going to jump to a different question, because that's twice now that I've heard see and avoid being used. So, Dr. Kastner, if you could talk about see and avoid, what are some of the benefits of it from a pilot's and an air traffic control perspective, but also what are some of the limitations of see and avoid?
Well, see and avoid is one of our most basic, familiar cognitive perceptual faculties. Is when we use our eyes, ears, and attentive minds to look out for hazards, anything that might get in our way. The advantages is we have a lifetime of experience of using it. So We don't need the user's manual. And then comes the problems associated with it, in that our ability to pay attention is very narrow. Even our focused vision, if you hold your thumb out at arm's length, that's about how much you can see in focus at any one time. You could hold a book or a page behind it, and if you stare right at your thumbnail, you find that you can't read the words even beside them. So that's quite limited right there. So we get good at knowing where to point it, and we also benefit greatly from any kind of clues, hints, tips, where to point our eyes in a complex situation. And the more we know, the more information we get, the better we get at it.
Also for you, Dr. Kasner, one of the questions that Mr. Soper asked of the panel members were some of the complexities of operating within the DCA airspace, and some of the things that were mentioned was a mix of traffic, the nearby airspace of other airports, prohibited areas, it's a small airspace. So we've got this high-density airport, mixed traffic with different performance capabilities. We've got nighttime conditions, we've got intersecting runways, we've got cultural lighting. So with all of those things, again, if you can speak sort of from the pilot's perspective, but also a controller's perspective, what do all of those complexities do to human performance and how we operate?
Well, they challenge it, for sure. It makes it harder. But again, the more I know about them in advance and the more information and support I get while I'm exercising that vigilance, the better it's going to be, certainly.
What about in terms of, if you can expand a little more, in terms of workload, situation awareness, how do we manage all of those things, and how are we able to do it? We know that controllers are able to operate with these complexities, so what are some of the processes that they go through? How do they manage all of this information in order to make efficient decisions?
It's all very challenging. And we get so many sources of information coming our way. So, for example, we talked about hearing other aircraft on the radio, what we call the party line. You gain so much awareness. You can gain so much awareness by listening to what other people are saying. What are they doing? What are they having trouble doing? Spotting another aircraft? I want to know if I'm that aircraft that they're having trouble spotting. You just take whatever clues are out there and, of course, provide as many as you possibly can with your charts, your ATC directives, your training, anything.
Speaking of charts, you're familiar with both helicopter and airport charts, given your experience. Looking at the DCA and the helicopter charts for this area, is there other information that you think is missing? More information is needed? Less information? Is there any insights that you have from a human factors perspective on the charts as they're currently presented?
Yes, I like both charts, and I would like them to be one chart. I would like the information on the helicopter chart to also be shown in some way on the airplane charts and vice versa. If there are helicopters operating in the vicinity of my approach course, my glide path, I at least want to know about that. And we spoke a bit about airport familiarity. That's just the kind of thing that I'd like to know when I'm coming to DC for the first time or the second time. The experienced pilot probably already knows about it, but for me coming in there the first time, it's the first thing I want to hear.
Some might argue that these charts are already full of information, and is there a risk that by putting more information, we're just cluttering the chart and that information is just going to get lost?
Yeah, you really have to weigh the costs and the benefits there. certainly more symbology on the chart is going to make it more complicated. But then what's the cost of not knowing about it at all? It's a tough needle to thread, but I think this one, there should be something there.
Mr. Banning's opening presentation, of the air traffic control audio. The controller was talking to a lot of aircraft at this time. We've got a helicopter that's got visual separation. So the expectation, of course, is that they're going to see and avoid. They said they have the aircraft in sight. What does that do to, from a controller's perspective, how does a controller, from the human factors perspective, so I'm talking to another aircraft, and how do I switch gears from this primary task that I've got aircraft calling me, I need to talk to them, now I need to shift gears and say, wait a minute, this guy who I thought was maintaining visual separation is now on a conflicting path with another aircraft. And so how does that information processing work, and how do we shift gears in order to, from that primary task to another primary task?
Well, I'm certainly no air traffic control expert, so difficult, but it sounds like workload and complexity to me. And another thing we call context switching. It's very difficult. Suppose you're having two conversations. You're talking to someone in the room and someone on the phone. It actually takes a while to go back and forth. You have to reload the details in your mind. It's the same thing we explain why it's dangerous to text and drive or talk on the phone and drive. Switching back and forth takes time.
Thank you. I appreciate everyone's responses. That's all the questions I have for now.
I'd like to shift to the history and activities of the DCA Helicopter Working Group. Mr. Allen, we learned through post-event interviews that there was a DCA Helicopter Working Group founded at the DCA Airport Traffic Control Tower that may have looked at these very concerns, and that you participated in the activities of this group for a period of years. Is that correct?
Yes, I was on the helicopter working group in the early 2020s through 2023.
Okay, perfect. Thank you. Could you please step us through the origin of the group, for what you know, and what was the catalyst of it being formed?
The helicopter working group, prior to me joining it, had always, as long as I had been at DCA since 2013, there was always some version of it. And as time went on, the panel members may have changed over the years, but it would consist of management personnel and NACA bargaining unit employees, and their level of involvement as they saw fit for the group.
Did this group have a mission statement, a statement of work, or anything along those lines?
I don't recall specifically.
That's fine. What organizations or personnel were represented on this group?
The group itself was contained within the facility. Like I said, it consisted of management personnel and air traffic controllers, bargaining unit employees.
Could you tell us a little bit about the activities of this group?
Yeah, the group would, they would meet, discuss any challenges, any operational challenges that they had seen, if there was any safety reports or data that was available, they would discuss that. We would provide, when I was on it, we looked at the mandatory occurrence reporting data as a driver for some of the changes that we were able to implement, and we would provide outreach to all the various user groups.
What were some of the participating user groups?
I can't recall specifically, but there was always multiple law enforcement agencies available, multiple medevac, and multiple branches of the military would be present.
What are some of the advantages to speak with the users and show them your operation? Would they also perhaps speak to their concerns with you guys?
Yeah, so it's a great tool to provide that outreach to the user group that you're servicing, providing services for every day as our customers, and vice versa, what we can do better for them. Anytime you can take the user out there in the airspace and put them together with the controller and share those stories, share that perspective, and get eyes on what each other's operation is, that's that much more knowledge that you can gain, that much more safety that can be gained by that.
Thank you. I appreciate that. Do you recall if, while serving on the helicopter working group, did the group ever propose changes to the helicopter route structure, which we've kind of already discussed Route 4, so we understand that portion. But did the group ever propose changes or any other operational safety improvement change recommendations that would pertain to operations within the DCA Class Bravo airspace?
Yeah, we proposed several others. We proposed lateral boundary changes to some of the zones, and in addition, altitude changes to certain zones and routes.
Was there any formal, safety risk management process conducted in assessing these change proposals?
Yes, and I forgot we did publish a new transition point further away from the airport for the helicopter users. Yes, with the changes, we conducted a formal safety risk management panel.
Do you recall the response provided or the disposition of any of the group's recommendations? And if so, how or from whom were you informed or advised?
We conducted the safety risk management panel after multiple rounds of meetings with the user groups and making adjustments as needed and settled on a final product. We conducted the safety risk management panel, and I believe the final document, there was no hazards identified with the changes that we were going to make. With that, since there was no changes left to make, we had environmental study done. That was completed, and the last part was charting the changes that we had proposed.
I'd like to get back to that Government Accountability Office proposal about the noise abatement in just a minute. But Mr. Fuller, having heard this information, do you recall ever being made aware of these proposals or having advised management at the district or facility level in responding to these proposals?
I believe the specific proposal he's discussing was in 2022, 2023, sometime around that frame. And those helicopter chart changes were made and weren't effectuated.
Okay, in 2019, this is what we were talking about just a minute ago, the Government Accountability Office was tasked with conducting a study into the problem of helicopter noise over the Washington, D.C. area after a spike in community noise complaints. It is our understanding that the DCA Helicopter Work Group reviewed these findings from the study and developed a series of recommended changes to the Baltimore-Washington helicopter route chart, which were presented at a helicopter symposium held in November of 2022. What are some of the changes that were presented at that specific symposium, Mr. Allen?
After the completion of the GAO study of helicopter noise impacts to, I believe it was out to a 30 nautical mile range from DCA, the regional administrator had come to DCA and shared the study with us and asked us to take a look at it and see, hey, is there anything better the FAA could do with noise? The local helicopter work group took that information, reviewed it, and then looked at our own internal safety reporting that we had and saw some areas where, hey, we could make this better. So we can improve noise and improve safety all in the same scope. So with that, we came up with the proposed changes that were implemented in June of 2023.
Upon reviewing your proposal during the helicopter symposium, I noticed that you had, Mr. Allen, your facility had hoped to chart hotspots on the Baltimore-Washington helicopter chart. Can you speak a little bit about what are the hotspots? What are hotspots, first of all? And what were you trying to do by requesting them to be put onto the helicopter chart?
So hotspots are an airport diagram depiction to show areas of concern on an airfield map. We were attempting to, since we were not able to change Route 4 and the proximity of some of the other routes or heliports or hospitals, we, if we weren't able to change them or, we can't move a hospital, then let's at least draw attention to it for the users. So our attempt was to take something similar on an airport diagram, apply it to the VFR helicopter chart, and draw attention to it since we weren't able to change the location of helipads or, in this instance, also a route.
Mr. Allen, what was the feedback received by, from some of the attending helicopter users about the proposal to add hotspots to the Baltimore-Washington helicopter route chart?
From my recollection, everybody was satisfied with, adding an additional layer of safety to the helicopter map.
Mr. Allen, as we spoke before, you mentioned that there was a safety risk management panel convened in approximately April 2023 to assess the potential risk of these proposed helicopter route chart changes to include the hotspots. You already kind of summarized. Well, could you please clarify, what was the findings? What were the findings of this panel? And did the panel agree with the proposal to chart these hotspots?
The safety risk management panel concurred with all the proposals and identified no hazard.
Thank you. Ms. Murphy, this is for you. FAA order, Joint Order 7210.3 outlines the procedures for requesting changes to aeronautical charting. What steps did your office take to address the request to chart the hotspots on the Baltimore-Washington helicopter route chart? And was there a formal response to the request?
Yeah, thank you. So Aeronautical Information Services did receive a request for multiple chart changes to the Baltimore-Washington helicopter route chart in June of 2023. We implemented all of the changes, as Mr. Fuller mentioned, with the exception of the addition of hotspots. Hotspots are associated with ground or surface movement and are not within the VFR aeronautical chart specification.
Is your group able to give suggestions as how to implement the intent of a hotspot without making it called a hotspot?
Could you clarify the question?
So I understand that hotspots are normally used for surface areas of confliction maybe, and that they want to bring attention to it. So it seems to us that this is something that maybe is this a new idea to try to highlight an area that is airborne, that is a potential for a conflict? Is there a way or a process that it could be put on the chart without calling it a hotspot?
Absolutely. Aeronautical Information Services hosts a biannual aeronautical charting meeting. Anyone, public, industry, is welcome to come and submit a recommendation document It's discussed amongst our aviation peers, stakeholders, the military, the FAA, and ultimately it's decided whether or not to implement the recommended change. So that would be one way of having a new charting symbol or something, some new feature charted.
Do you know if that information was passed back to the facility?
I don't have evidence to confirm it. However, it is the standard operating procedure to always suggest that as a conduit to have a chart change.
Okay, thank you. I think I'll pass it to Van. Thank you.
Okay, before I get into ADSB policies and procedures in the airspace, I have a couple of follow-up questions I'd like to ask. Mr. Allen or Mr. Fuller, the FAA said that earlier that the altitudes on helicopter routes were recommended altitudes. So does that mean those operating those altitudes can vary on the route unless otherwise instructed by ATC?
Yes, those are recommended altitudes on the charts. They are not regulatory in nature. These are VFR charts. Those aircraft do have a requirement to maintain clear of clouds, avoid other aircraft, maneuver as necessary. If air traffic needs a specific hard altitude in Class B airspace, they will assign it. There are some helicopter charted areas that only mention an altitude at or above or at or below and don't have a finite altitude for helicopters to maintain. And I'll pause here and see if Mr. Stowe would like to provide additional information based on his technical knowledge.
Yes, that would be accurate, especially considering there are specific pilot requirements for Title 14 CFR 91-119. There may be other pilot limitations, such as Part 135 operators, for example, have a minimum safe altitude of 300 feet, so they would be unable to comply. It would be the expectation of air traffic that if, in the event, a pilot would require a different altitude than one that's specifically assigned, that they're cleared on, or assigned, that they would advise air traffic.
So if a pilot's not assigned an altitude but cleared for the route, should they consider that hard altitude symbology on the chart as their assigned altitude?
I think it would, I would have to review the specific phraseology and the details. To refer back to the helicopter route charting program, I think it's the subparagraph B or in the initial part of the paragraph. It may also be dependent on any specific language in a letter of agreement with certain operators. So I think I'd have to have some context or a specific example.
Okay, thank you. And Mr. Van Vechten, you mentioned that you did not believe that the clearance between Route 4 and visual approach to runway 33 were vertically separated. Is that correct in your earlier statement?
I thought the procedure was we were not allowed to utilize Route 4 and cross the departure path of 1533 or the approach path if there was landing traffic.
Okay, so then you think that there wasn't vertical separation between the route and the approach to 33?
I will say I assume that there's insufficient vertical separation, and that's why I was never allowed to cross the approach path.
Okay, we did talk to some other pilots, and they thought that there was some vertical separation, other pilots in the battalion. Can you maybe give an explanation of why some pilots thought there was vertical separation and some pilots didn't think there was vertical separation on that part of the route?
No, I can't explain that, sir.
All right, thank you. I'm going to go into some ADSB policies, this line of questioning. So, Colonel DeForest, What was the ADSB use policy for the 12th Aviation Battalion at the time of the accident?
So at the time of the accident, and this is always the case, we, our battalion's entrusted with the lives of some of our most senior leaders, so both safety and security. So applying risk management procedures at the time of the accident, we perceived the risk of security as paramount. Knowing ADSB out, what that the signals it sends out, we assessed that was a risk that could be mitigated. So the policy the day of the accident was to have ADSB out, off, anytime you are conducting anything related to the mission, i.e. flying near a mission route or location.
And what guidance did you have to develop this policy?
At the time of the accident, it was Army policy, and which we were in compliance with, in addition to the MOU between the DoD and the FAA.
Okay, thank you. And when the aircraft are operating ADSB out off, are they required to broadcast mode C, mode 3A and C?
Yes, they are.
And one part of the SOP states that the air crews are not to change transponder modes in flight. Could you explain the rationale for that?
I believe the rationale because in the Lima model helicopter, it's several steps that you would not perform in flight.
So that's a system limitation and not necessarily a policy type of guidance?
To my understanding, yes. It's approximately 20 things you must do as an aircrew member with your heads down to make that configuration change.
Obviously, and you didn't want your air crews doing that in flight. Understood. From your knowledge on the on PAT 25's route of flight, were they utilizing mission routes or mission sites that would authorize them to use the ADSB out-off policy of the SOP?
Yes, they were.
Thank you. This question is for Mr. Dressler. How does the prevalence of non-ADSB out flights impact the operation in the DCA Class B airspace?
It adds an unacceptable layer of complexity and risk to this system. So when you look at the flight profiles, and if we talk specific to night NVG operations, and we've heard how stressful and how demanding those flight regimes are, then when you are being given traffic information from ATC, which you may or may not, most likely, be unable to see, it's remarkably difficult to see an aircraft at distance, and it becomes obviously quite easy within 2 miles or a mile. So in the way that all of the civilian helicopter operators are configured, including law enforcement, is we have a traffic avoidance system. It's not TCAS, but it's TCAD, and it is ADSB dependent. So when you are scanning, goggles or no goggles, looking around your goggles, and you can or cannot identify an aircraft, your next step in your situation analysis is to scan your traffic system. Well, that's completely useless if aircraft don't show up because they're not broadcasting. So it adds an enormous risk that, in fact, having talked with other DoD units, I do believe there is a specific use case, limited specific use case, and I think that the other units that we've spoken with, which I don't think I should name publicly, but the other DoD units, with their national security mission in very specific circumstances, I think your question, I hope your question is more about the general application or lack of use of ADSB, and the user group finds that to be an enormous risk.
Thank you. How often do you observe helicopters within the DCA Class B airspace operating with ADS-B out off?
Every day,
Every day.
including to this day.
And for those situations, what is your primary technique for avoiding that traffic?
We rely upon air traffic control for Class B separation. Primary, to repeat myself from earlier, would be see and avoid, and take whatever steps necessary to change our route, our altitude, our airspeed to avoid, and further try and emphasize on frequency, make a call that might restate that we're operational. So a law enforcement member might have notified air traffic control that they're on an orbit, on a mission orbit, and perhaps the air crew of the other aircraft, specifically DoD aircraft, may not have heard that. Maybe they were coming off of another frequency, transitioning, say, from Andrews into DCA. So my third answer to your question is we'll restate our mission profile in hopes that that other aircraft is now alerted to the fact that there's an operational aircraft in the way.
Thank you. This question is for Mr. Allen. How does the prevalence of non-ADS-B out flights impact air traffic operation within the DCA Class B airspace?
With our STARS radar that we use with fusion mode, the ADS-B out off has no impact.
Would an air traffic controller know if an aircraft was or was not transmitting ADS-B then?
No, we're not required to have that capability turned on the radar screen.
Does having aircraft with with ADS-B out off, does that impact any of the ATC services that you can provide?
No.
From an ATC perspective, is there any safety or operational benefit to aircraft that are operating with ADS-B out on?
Not that I'm aware of.
All right, that concludes my questions.
I actually have one follow-up question here that we were discussing. I hate to go back to this one same area again. We're talking about the routes, the altitudes of the helicopter routes, and it's been stated that those are recommended altitudes. And we heard Mr. Fuller explain how, or I don't remember if it was Mr. Fuller, but explain how, they have a whole lot of other things they got to do, remaining clear clouds and remaining clear of obstructions. They're flying VFR, CNBC, and all that stuff. So you can expect some variance on that route. The question would be, though, what's the purpose of an altitude cap if it's recommended? And what would air traffic control do anything? So I'll make this question for you, Mr. Allen. If air traffic control observed a helicopter on Route 4 in an area that had a 200-foot recommended altitude restriction, would you say anything seeing that aircraft over that, coming up above that altitude? Would that prompt a control instruction from you?
Yes.
Okay. Why?
The way the helicopter chart is trained within the facility, that the altitudes and the zone boundaries and such are need to be followed by the air crews.
Okay, so how much of an altitude variance would prompt you to have them check altitude or to give them a restriction, or how long would it have to be there before it prompted you to do something? Is it something that is, as soon as you've seen it, you would do it, or you would watch it? How does that work for an air traffic controller?
I think it would be controller specific.
Okay.
And situationally specific.
Okay. All right, thank you.
One follow-up with that same line of questioning from Mr. Soper. So you just said it was controller specific. So is there any FAA guidance in terms of altitude deviation when you should start talking to a flight?
Well, this is a VFR chart with suggested altitudes. The facility within itself trains that the helicopters need to be at those altitudes. So a controller, if they notice them leaving it, maybe they'll wait a second and see that it comes back down, or maybe they take action immediately. It's situational and controller dependent.
Okay, so no set FAA policies, just up to the controllers to take care of it. Mr. Fuller, did you have a comment?
Yes, sir, Dr. Bauer, if I may add in. Ultimately, the controller is responsible for ensuring positive control and preventing a collision. And so if that altitude was needed to ensure separation, our expectation would be that controller would assign that altitude specifically to maintain, if that was the only barrier they had for separation. If they were going to allow that aircraft to go up or down, they have other tools they could use, like radar vectors, to do a 1.5 mile separation in lieu of the 500-foot vertical separation requirement. If they're solely just relying on altitude, our expectation is the controller would maintain positive separation as required in Class B airspace.
Thank you very much. That completes the technical panel's questions for the moment.
Thank you very much, Dr. Bauer. Normally, I'd say we could take a break, but I actually don't know if the restrooms are working. So if you have to go to the restroom, I'd say go ahead, but we're not going to take a break. We're going to go right to parties. So we are going to go ahead and start with the U.S. Army in reverse alphabetical order.
Thanks, Madam Chairwoman. Just clarification for the FAA. We talked about within the Army conducting, on the night of the 29th, conducting what we would call an annual proficiency evaluation test. Do commercial carriers and other activities conduct similar tests within Class B airspace?
So there are training flights, much like the military conducts training flights. Air traffic would have no way of knowing that unless a pilot disclosed that. We provide a service if it's a practice approach, ILS approach, things of that nature, but we don't specifically ask that of pilots.
But specifically for commercial traffic, there are operational check flights that occur in the national airspace in places like DCA. Is that a correct statement?
I believe so. I know there's a special pilot certification that you need to land and operate within DCA. I would defer the question to some of our airline colleagues here to answer that specific point.
Okay, thanks. No further questions.
Thank you very much. Sikorsky.
Sikorsky has no questions this time, ma'am.
Thank you very much. PSA.
Thank you. Mr. Allen, you were discussing the moving of Route 4 out to 295, and in that working group, you were talking through that for continuity of government or security, it wasn't moved. Who told you all that you couldn't move it?
Those discussions occurred with the user groups and management within the facility.
So you don't know who did it? Was it documented in the SRM? I mean, obviously a risk or a hazard was identified. Was that not documented?
The SRM was for the proposed changes to go into effect. We never got to that stage with Route 4. So it wasn't part of the panel.
Okay. I don't understand if there was a risk or a hazard that was identified. It wasn't documented, is what you're saying of Route 4. Somebody wanted it moved, right?
Correct.
And they wanted it moved for a reason, that there was a risk or a hazard.
Correct.
But there's no documentation of that in the SRM?
Sir, if I may just clarify. So SRMs are primarily used for changes to the NAS. I think what Mr. Allen is discussing is they were ideating on potential hazards, never got to the point of formally proposing as a change. They went forward with additional changes that were effectuated to the system, and then for those changes, we did have to do an SRM panel on. And so I think the point that he's talking about was just in the discussion phase.
Gotcha. So whenever you guys do a management of change, is what you're doing for any charts or anything like that, you don't risk assess?
Ideally, that would have been captured in their local safety council documentation, but it wouldn't have made it to the formal SRM documentation. And I don't know if they captured that. I would have to, again, discuss with Mr. Allen and see what documentation they kept back then. I was not a member of that particular work group, and as an external member, I wouldn't see what they locally documented.
And this is back in 21 to 23? You saying back then?
Mr. Allen, is that in your 21 work group?
Yes.
Okay, thank you. Okay, sorry, I'm trying to. During this working group, Mr. Allen, was there any consideration to establishing lateral boundaries for the routes, particularly Route 4?
No, there was not.
None at all. Thank you. I guess getting back, was there any written SOPs between ATC and the Army battalions on that prohibited traffic from proceeding down Route 4 when there's landing traffic in 3-3?
No.
That you're aware of?
No.
Mr. Van Vinkton? I know you mentioned that you've never went down Route 4 when there was landing traffic. Was there a written policy there or anything between the two where you didn't do that?
No, sir. I was not aware of a written policy by ATC. I just assumed that it was prohibited or not allowed.
Okay. Sir? Colonel DeForest, you said your mission required regular realistic training in the event of continuity of government situations which require the evacuation of government senior leaders. Do you anticipate during that commercial air traffic wouldn't be stopped?
Tough, realistic training has to, if you think of the different scenarios, our response times are very quick. And I'll use 9/11 as an example, the amount of time it took for commercial traffic to land. It probably was minutes, less than an hour across the entire country. So we have to factor in there will be commercial traffic in this airspace.
So there would be time to clear the traffic is what you're saying? Sorry.
That is correct.
Yeah, okay. Just curious. All right, Mr. Allen, Mr. Murphy, if the helicopter routes have no lateral boundary, is there some limits to how far off the line the helicopter can go?
It's an air traffic control decision.
There's no charted limits.
So, as you know, in this accident, they were not on the left bank. Obviously, they were coming toward the center of the Potomac there. How far over do you let them go? There's no lateral boundary.
As Mr. Fuller stated earlier, it is a VFR chart. The altitudes are recommended. There is a key that describes the route of flight for the helicopters. but it is incumbent upon the helicopter to report locations and air traffic control to provide the Class Bravo services.
And sir, we are working, our current helicopter working group that is active at this time is working with our users to establish lateral widths to those helicopter charts, and along with compulsory GPS reporting points. So yes, we didn't in the time have those in effect, and we currently don't at this time, but the long-term goal is to have defined widths and reporting points.
Thank you. I see I'm out of time. Thank you, Chair.
Thank you very much. And we will go to NADCA.
Thank you, Chairwoman. First question is for the U.S. Army. Mr. Van Vetjen, could you let us know, or could you advise if the pilots or the flight crews are able to monitor multiple frequencies while operating the helicopter?
Yes, you can. Most of the UH-60 Limas in 12th Aviation Battalion are outfitted with ARC 231 multiband radios. So I can have 2 VHF radios and 2 FM radios. But there are some legacy aircraft where it's 1 VH, 1 UH, and 2 FM radios. So we could monitor multiple radios at the same time.
Thank you. Was it common practice or recommended for the air crews to monitor both local frequencies when operating on any of the helicopter routes?
No, it was not.
Okay, thank you. And then just going back to your time operating, and you spoke of operating on Route 4 with, but not with aircraft landing runway 33, thought that was prohibited. Were you ever operating on Route 4 with aircraft arriving or departing National Airport?
The airport in general, yes, sir.
Thank you. Just over Mr. Stowe or Ms. Murphy, just regarding the charted helicopter routes, are they considered ATC instructions?
No, they are not. They're recommended paths.
Okay. And then if the paths are only recommended, how does one know when to use the recommendation or not? What is the expectation?
To follow air traffic control guidance.
So they would be cleared on the recommended route?
That is my understanding.
Okay, thank you. And then just with the design of the route, is the intent of the route to be separated from other routes or other obstacles, aircraft, anything along those lines?
I don't know the answer to that.
I can add that it's probably very situationally dependent locally on what I guess the needs are of the facility. It probably depends, or I would suggest it depends heavily on complexity, need to standardize, or, I guess, standardize the traffic flow for the purpose of ensuring separation. And would defer to DCA locally as to whether or not that's something they desired or had built in.
Thank you. Mr. Allen, did you believe Route 4 was separated from the runway 33 arrivals?
No.
Thank you. And then Route 4, the helicopter Route 4, do you believe it provided a benefit to the operation?
It provided a benefit to expedite the movement of helicopters.
Thank you. And then, Mr. Fuller, just a follow-on question from earlier. Air traffic, I think you stated something along the lines of air traffic is required to separate the aircraft operating on Route 4 from other aircraft. Could you explain the tools or the methods that air traffic control can use to separate helicopters, for example, from aircraft?
Absolutely. They can assign altitudes. They have a certified tower radar display, and they're trained on providing suggested headings, altitudes, courses to deconflict those aircraft. In addition to visual holding is another tool. They can instruct the helicopter to hold at a prominent obstruction like Haynes Point, like was previously mentioned. There's a myriad of options for controllers in Class B to provide positive control there.
And thank you. And I should have mentioned pre-accident in the rules. Is there any rules in place that can transfer the separation responsibility from air traffic?
Yes. Prior to the accident in the DCA class Bravo airspace, if the pilot reports traffic in sight and advise they will maintain separation from it, the controller only need to approve it, the operation, or they could issue the traffic and then instruct the pilot to maintain visual separation from that aircraft. They are still required to maintain Class B separation before and after the application of visual separation. And in that particular case, in this operation, they would normally advise the other aircraft that traffic hazard inside is maintaining visual separation.
Thank you. No further questions.
Thank you very much. FAA.
Thank you, ma'am. Chief Warrant Officer Van Vechten, can NVGs be qualified in a simulator?
No, you cannot.
Okay. Mr. Stowe, if routes are not procedurally separated, what's required to maintain legal separation in Class B airspace?
In Class B airspace, it would be dependent on a number of the tools previously mentioned by Mr. Fuller. The radar separation requirement would be 1.5 miles and 500 feet for a VFR target from a IFR, VFR, or fixed-wing aircraft weighing 19,000 pounds or more, or target resolution or 500 feet for aircraft if it involves aircraft weighing less than 19,000 pounds. There's also tower-provided visual separation that's an option, as well as visual, as was previously described.
Thank you. Mr. Allen, for visual separation, once approved, who's responsible for maintaining that visual separation?
Are you referring to pilot or tower applied?
Pilot.
Pilot applied, it is incumbent on the pilot.
Thank you. That's all I have. Thank you, ma'am.
Thank you very much. ALPA.
Thank you, Chair. First question is from Command Chief Officer Van Vechten. How often are routes 1 and 4 used for night vision goggle check rides?
I would say more often than not. It was one of our primary routes, and in my opinion, I saw it as one of the safest routes because 96% of traffic utilizes runway 119, so 96% of the time you're parallel with traffic, and it's not a factor.
So that would be the why then for this case is why it was used.
Correct, yes, sir.
Just to follow up, so you say that it's 96% is mainly going to runway 1, but even so, this is a complex airspace. Do you think it is an airspace where potentially we could limit NVG check rides and do those someplace else, where it would be potentially more beneficial to get away from the congestion?
Because of the unit's mission, I do not think it would be more beneficial to move the annual check ride from there. You must be familiar with your airspace that you're expected to operate in when conditions are not ideal. So on a check ride is when we would train those pilots to fly there.
Is it possible to do something more in lines of a familiar, like a FAM flight versus an actual check ride in that space? Because check rides, at least in my experience and understanding of it, it's a bit more of a high-pressure situation for a pilot being evaluated.
Sure. Local area orientations are always conducted prior to the check ride. You would never take your initial flight in the DC Helo routes as your check ride. The DC Helo routes, Route 1, 3, 5, and 1, 3, 4, 5, and 7 are part of the local area orientation checklist. So you must have seen those routes prior to taking a check ride.
Okay. Was there any Army guidance to maintain a minimum lateral distance from the shoreline?
No.
Okay, so there was no internal of, hey, we fly right over the shore or hug the shore, maybe not written anywhere, but sort of procedural or technique only?
Yes, sir. We'll call that tribal knowledge is hug the shoreline while traveling south or northbound, unless you have opposing traffic and you have to utilize rules of the road.
Of course. Is there a safety or risk assessment that is accomplished prior to each helicopter training or operational flight?
Yes.
Are air carriers and proximity to runway environments included in that assessment?
No, they're not currently on our assessment.
Okay. This is going to be, we'll pivot to Colonel DeForester. From an Army organizational perspective, was a risk analysis ever done on operations in DC airspace?
It would have been included in the previously referenced risk assessment. So we have, part of the risk approval process, you're going to receive your mission, You'll do detailed planning, rehearsals, map rehearsals, TTXs, talk to your briefing officers, things of that nature. So yes, we do conduct rigorous risk assessments prior to each flight.
So it is specific then to the individual pilot risk assessment that that pilot does and then brings that to specific other personnel within your structure.
Absolutely, and there's a lot of different considerations. You know, you're going to look at the crew, the composition of the crew, the environment, the tasks to be trained. So all those items that introduce, or those aviation risk factors are discussed.
And once again, just to clarify, was runway 33 approach traffic included specifically in this risk analysis?
Not on the 29 January risk analysis, or RCOP.
Was it in general, and is it now, like in general, was it ever included?
It is now, after the accident.
And were also the limitations of seeing traffic with cultural lighting under NVGs in that specific area also considered?
On the day of the accident, or the night of the accident, yes, that's
Or
included.
any previous with cultural lighting in that specific area? Is it just a general practice to consider cultural lighting in that area?
Absolutely, time of day, cultural lighting, illumination, weather, things of that nature, so yes.
Thank you, sir. Back to you, Mr. Van Vechten. Just to clarify once again, I'm sorry we've asked you this point so many times, but you were under the impression that procedurally helos were required to hold if aircraft were landing on runway 33. Is that correct?
Yes, sir, that's correct.
So if you were cleared to transit onto Route 4 and then were told there was traffic circling to land at runway 33, would you have assumed there was procedurally something incorrect and that you were potentially in conflicting airspace?
Hypothetically, if that had happened, I would either query Tower, or I would probably at Haynes Point have made a left turn to go northbound on Route 1 towards Greenbelt.
Or possibly just hold at Haynes Point as well?
Correct.
Okay. Another one for you, sir. What is your normal crew composition for night training missions?
What do you mean night composition, sir?
Specifically, is there a minimum requirement for your crew to crew the aircraft? I'm assuming left seat, right seat, and then one crew chief in the back?
Yes, sir, that's the minimum. Pilot, co-pilot, and crew chief.
Was there ever consideration given to doing 2 crew chiefs in the back to increase see and avoid potential or just visibility outside the aircraft?
There are certain mission sets that require a second additional crew chief. External load operations, medevac operations will have a second one, but an additional set of eyes doesn't necessarily increase safety. In this case, the crew chief was sitting on the left side, so in the best position to see the aircraft. So an additional crew chief would not have increased the safety.
Thank you, sir. That's my time.
Thank you very much. Before the second round by the parties, we're going to go ahead and take I'd prefer a 10-minute break so we can get back into it. I'm going to ask if there is a line that people let the board members go first in the restroom so we can come back and convene everyone. Sorry to pull rank there. Thank you so much.